CH2, CH2. Bam, I can't put one CH3 here. Look at that. So I can have this. If you count very well, you're still going to have the same thing. 1, 2, 3, 4, 5, 3, 4, 5, 6, 7, 8, 9, 10. You still see 5H10. Then after you have drawn your structure, try and name it. Now, if you want to name, I can just do like this. I can start my counting from here. 1, 2, 3, 4. Mr. Adams, why is it on CH2? Yeah, the second hydrogen has been replaced by this methyl. So I want to name this one now. Class, if there is no methyl there, we're going to be having CH2 all round. Class, if I'm having CH2 all round and there are 4, what will be your name? If you're having CH2, 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 and there's no methyl there, what's your name? If there are 5, what's your name? You can't get 4, what's your name? Cyclobutane. So what's the name of this guy now? 1-methyl cyclobutane. 1-methyl cyclobutane. One methyl, please help me touch that one. Please sit very well. We're just starting, you know when this guy is going to end? I don't know. That's why we're on question 1. And we're going to solve 100 questions, 50 physics. So if you like, sit anyhow. So that's 1-methyl cycle. And put your mind. Exam is 41 days. I see my agbada for wedding is here. I have 2 weddings today. One of my sons, one of my daughters. I'm the chairman for one. If I can make it, I will. If I cannot make, so please put your mind though. 1-methyl cyclobutane. Let me draw another one for you. I'll do like this. Mr. Adams, what if I remove this CH3? I can't put on here. Would the name now be 2-cyclobutane? 2-methyl cyclobutane? No. Anyway, you put, if I remove this one, maybe I come and put the methyl here, and this one now become hydrogen. You are going to start your numbering from where you have the methyl. So if the methyl is here, you still call it 1. You still call it 2, you still call it 3, you still call it 4. Am I communicating? So it is where you have the methyl that your numbering starts from. If you like, put the methyl here, you are still going to call it 1, like that. So it's still the same thing. Oh yeah, now. Can I draw another structure? Of course. Can draw this. CO, C, CH2, CH2. Okay, maybe I should put this one first. CH3, CH3, and then CH2. Count. Let's count now. How many carbon do we have altogether? Be active. Be active. 5. How many hydrogen altogether? How many hydrogen? Are they having the same molecular formula? They are having the same. So they are isomers. Oh yeah, now. Who can try to name that compound for me? Where is Debola? Yes. Name it. What would the compound be? Can you see the screen? Yeah, that's my baby girl. That's perfect. So you can do like this 1, you go like this 2, you go like this 3. So methyl on carbon 1, that's 1. Methyl on carbon 2, that's 2. There are 2 of them. What's that? Dimethyl cyclo what somebody? Cyclopropane. Cyclopropane. So already I've gotten 3 isomers. So is that all? See another one. Let me try another one. C, CH2, CH2, CH3, CH3. Count how many carbon. How many carbon do we have? I can't hear you. How many hydrogen? 10. Miss Summer, can you name that compound? Stand up. Try and name. Just calm down. Don't rush. 1, 1, dimethyl. That's my baby. That's correct. 1, 2, 3. That's it. So this on carbon 1. On carbon 1, that's 1, 1, dimethyl. Cyclo what class? cyclopropane. So how many isomers do we have now? 4. That's the answer. I'm not just interested in I got it, I miss it, but you're knowing it. And not guesswork. You don't have question, raise your hand. We'll see how many questions. Come and collect quickly. Those are in the ground floor. Can't see very well. There are spaces at the top floor here, at the middle floor here. Where are you coming from? You have been on holiday for 1 week. Welcome, man. Apart from the first floor, others adjust your share forward in the middle floor. If you don't adjust, no school on the 2029. So that I have some day students coming to class now. Their Zoom is not working. Welcome. Come and take part from the front. So everyone not moving their own. Okay, no problem. So the answer is 4. Now, I can represent all this structure. If I don't want to draw it like this, see another way of drawing them. Cyclopentane. If I want to draw cyclopentane, do like this. When it's something like this in the exam, this is cyclopentane. Cyclopentane. Don't put double bond though. So this is cyclopentane. Just like pentagon. 1, 2, 3, 4, 5. Then, if I want to draw one methyl cyclobutane, do like this. 1, 2, 3, 4. Just put 1 here. That's one methyl cyclobutane. That's it. Just get on top. One methyl cyclo what? Cyclobutane. Then if I want to draw 1, 2 dimethyl cyclopropane. So you know what to draw? Just draw triangle. Have you now? Come put 1 here. Put 1 here. Put another 1 here. There's 1, 2. 1, 2 dimethyl cyclopropane. 1, 2 dimethyl cyclopropane. And then the last one. I'll draw a triangle like this. 1, another 1, There's 1, 1 dimethyl cyclopropane. So now basically, class, how many hydrogen difference do we have between the normal alkane and cycloalkane? 2. Don't be laying like that, small. Forming note for yourself. So you can see, we have spent almost 30 minutes or more than that on one question. But I'm not just giving you answer, spinning. Let's go to 42 now. Far from what you have explained, some questions we start answering, Abby. So 42. 42 says the structure of cis. Now you know the meaning of cis, Abby. What's the meaning of cis? They are on the same order of trans. Diametrically opposite. Cis put 2 in. So that would be because they mentioned put 2 in. Like this. But I think I've even given this structure today. That's it as an example. That's it. Option what class? Option B. Says put 2 in. Option B. Chidera, stand up. That option A, can you name it for me? What is that option A? Don't rush over. Oh yeah. How many carbon do you have on the straight chain? So what is 4? Boots, not butane. Boots. You understand? Because if you say butane, that means it has single bond all through. You understand? Butane, very good. Then now look for where the double bond is. Where is the double bond? After which bond? After the second or the third or the fourth carbon? Carbon. So the name will not be boots 4, because there are 4. Then 2, because that's after carbon 2, that will be boot 2 in. That's it. Sit down. Boot 2 in. Boot 2 in. Glory. Where's glory? Yes. Option D. What is the name of that option D? Stand up. Try. Yes. 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 Methyl. Did you number the something? Did you number it? Don't use your hand. Number it. Use biro to number it. Oh yeah, name it now. 1, 2, 3, 4, 5, 6, 7. Sit down. To sing. Name the compound. What does that mean? Sit down. What people have been taught naming? Where is Sarah? Yes, Sarah. What's the name of that compound? Pardon? Eh? Can't hear you. Sit down. Not too far from my class. Ushe. What's the name of the compound? That for the 2 option. Option D. Cherish. Try. What's the name of that compound? Fast. I don't have time. Okay. Sit down. I can say that you don't know chemistry now. Because that's what you have been taught. So if you can taught that or naming of chemistry, organic, and then you don't know it. CH3, C is not, there's not like 1. What is 1? What of you are saying 1. Who taught you that one? What do? You number them. Number them. I can start my numbering like this. 1. That's what you don't want to. No. You start from the longest. This is the longest chain. 1, 2, 3, 4. That's the name. That's numbering. It's not 1, 1, 2, trimethyl. You know, just a 1 and 2. No. It's a chain. It doesn't have to be list. You know, I'm happy because that's why we are doing revision. All of you should not feel bad. They're all my daughters. So you have 1, 2, 3. Not like this. Not 1, 1, 2, trimethyl. There's one like that too. That's abuse of name. So you're going to start like this. 1, 2, 3, 4. The only guy that was not numbered is this one. It was not numbered. So the guy become a substituent. He become what? Substituent. So the name will now be what? 2-methyl boots 2. That's it. I'll come and sit here. Sit. That's it. As a serious girl, its room is not working. They are here, day students. There's some hostel students still sleeping now. Go and check their hostel. Why are you not here? I have cramps. Oh yeah, I like that. Please allow my girl to pass. That's it. 2-methyl boot 2 in. You know that some people are at the ground floor now, still playing. No wala. Oh yeah, now 43. Everybody can get 43. Olivia, what's the name of coin 43? 3,5 dimethyl so you have CH3, C, CH2, CH3, double bonds. This is the most interesting topic in chemistry. And you can see 10 questions came out this year on that exam. 10, 41 to 50. So you say, I don't know it, I late it. That's how you're going to make 20%. And I'm not making mockery. I said it's the most interesting. That's the truth. Look at this. Let's name now. That's how the structure was drawn, Abby. Number the longest chain ever. So the longest chain will be, look up. Can I start like this? If I can go like this. 1, 2, 3, 4. So can we go like that? Yes. Now 1, 2, 3, 4, 5. No. 4, 5, 6. And because we didn't number this guy, it will be a substituent. We didn't number this guy, substituent. And from the same, yeah, the same CH3. So the name will be 3, 5. This is carbon 3, carbon 5, dimethyl, because there are 2. X3. That's the name of that compound. Somebody says, sir, I want to number it the other way around. And she went this way. 1, 2, 3, 4, 5, 6. Now, if we number this way around, I didn't number this guy. This is on carbon 2. And this is on carbon 4. So the name will now be 2, 4, dimethyl X3, not 4. We are numbering like this. 1, 2, 3. It's not S4. S3 in. Now, this X3, that means the two of them in terms of X3 is correct. You now look at the sum of the positions. The one that will give you the smaller sum is the correct answer. What is 3 plus 5? What is 2 plus 4? This one is now wrong. That's it. But I'm happy my girl there got 3, 5. But you can't make that mistake again in the exam. That's what they call revision. Nobody's clapping for who got it, who missed it. Just make sure you are revising. So the answer is 2, 4, dimethyl. Can you see that 3, 5 also is there? Is there? You are this student, raise your hand. Those of you are just, God bless you. Sorry for the Zoom. I'm happy for all of you. Sorry. The Zoom reached the capacity this morning. But we will definitely pay for the expansion. Daniel is working on it. So if you don't have question, please come forward and collect question. If you don't have question, come forward and collect. Okay, then let's go to 44. 44. Number 44 says CH3. Have you thought alkane? This sodium. This liquid ammonia is called ammoniacal liquor. It's called what? Somebody? MP. Now, look up. This is the general formula for alkynes. CnH2n-2. That means we can represent alkyne like this. R. You have triple bonds. You can put prime here, or you can have R. You can represent alkyne that way. Now, the first one and the second one, they are both alkynes, but they have triple bond. The second alkynes are called terminal alkynes. They are called what? So why? Because the carbon having the triple bond has hydrogen. So when you have hydrogen like this, you are terminal. You are what class? And that this one now is synonymous to this one. See? C and H. But if you don't have hydrogen here, you are non-terminal. You are what class? And those terminal alkynes are very useful to us in chemistry. They behave like acid. How does acid behave? Acid can donate their hydrogen when they are reacting with what? Metals. Look at this. This reaction. Mr. Hydrogen, get out. Okay, sir. Hydrogen, come out. Yes, sir. Displacement reaction can occur. Displacement. So can have sodium chloride and then hydrogen gas liberated. So the terminal alkynes, you can do the same thing. Sodium, I'm coming. Oh, yeah, get out. And the sodium will just displace this guy. And the hydrogen will just disappear. So at the end of the day, I'm going to have something like this. I'll give you a short note. CH3, C, triple bond, C, Na plus hydrogen gas. So this is our product. That's our P they're looking for. That's our product. So let me write this to everybody. Alkynes, write it. This one, this two. Write the formula first. I can give you a short note. If you don't have question, come and take question. We'll see how many questions here. Right. The first compounds are called non-terminal alkynes. The first compound are called non-terminal alkynes. The first compounds are called non-terminal alkynes. While the second are called terminal alkynes. The first compounds are called non-terminal alkynes, while the second are called terminal alkynes. Are called terminal alkynes. Are called terminal alkynes. Full stop. For the terminal alkynes, comma. For the terminal alkynes, comma. Their hydrogen can be replaced by metals. Their hydrogen can be replaced by metals. The hydrogen can be replaced by metals. The hydrogen can be replaced by metals. Full stop. Non-terminal alkynes, terminal alkynes. Terminal alkynes. Terminal alkynes will react. Terminal alkynes will react with ammoniacal copper chloride solution. Terminal alkynes will react with ammoniacal copper chloride solution. Terminal alkynes will react with ammoniacal copper chloride solution. Will react with ammoniacal copper chloride solution. to form red precipitate. Ammoniacal copper chloride solution to form red precipitate. And silver nitrate solution. And silver nitrate solution. And silver nitrate solution to form white precipitate. And silver nitrate solution to form white precipitate. And silver nitrate solution to form white precipitate. To form white precipitate. Full stop. Non-terminal alkynes, non-terminal alkynes, and alkenes. Non-terminal alkynes and alkenes cannot, non-terminal alkynes and alkenes cannot undergo similar reaction. Non-terminal alkynes, non-terminal alkynes and alkenes cannot undergo similar reaction. Alkenes, A-L-K-E-N-E-S, cannot undergo similar reaction. Let me ask you a question, class. This one, H, C, triple bond, C, H. Is it terminal alkynes or non-terminal alkynes? Because it has CH. It has CH. CH3, C, triple bond, C, CH3. Is it terminal or non-terminal? Non-terminal. Where is the CH that you saw? Did you see CH around the double bond like this? I gave you now. See, this is non-terminal. This is terminal. For you to be terminal, you must have CH. CH. This one no get CH. Now CC get. This is not CH. This H3 that you have here belongs to this guy. It's not for this carbon. Oh yeah, CH3, CH2, C double bond, CH2, CH3. Is it terminal or non-terminal? Non-terminal. You must have C and H alone. Not something like this. This is not CH alone. It don't end. Bam. It can't end. Nobody say they got CH2, CH3. No. It don't end. This terminal. What does that mean? Listen to me. Get this thing right. It comes out in the exam every time. Once you are terminal alkynes, what does that mean? When you react with ammoniacal copper chloride, you will get red precipitate. This is terminal, for example. Terminal, alkyne, ethyne. When you react with what again? Listen to me. When you react with ammoniacal silver nitrate, you get white precipitate. We call it metallic derivative. When you react with ammoniacal copper chloride, what do you get? Red precipitate. Ammoniacal silver nitrate, they call white precipitate. But Mr. 18, look at 18. Mr. 18 can never do that. Mr. Adam, what are you talking about? I'm talking about the fact that although ethyne and what? 18 are both unsaturated hydrocarbon, they will both decolorize bromine water. But when it comes to reacting with silver nitrate, this guy will say, I know they do. I know they react. So when he asks you in the exam, what chemical reaction or what physical test or chemical test can you use to distinguish between ethene, E-N-E, and ethyne? Then that's the reaction we're talking about. The two of them are both unsaturated. They can decolorize KMNO4. They can decolorize bromine water. But when it comes to reacting with ammoniacal, this is liquid ammonia, ammoniacal silver nitrate, this guy will say, I know they react. No reaction. This again, we react. That's the meaning. Because ethyne is a what? It's a terminal alkyne. But don't forget, listen to this grammar very well. But not all alkynes can do that reaction. Not all of them. Mr. Adams, can CH3, C, triple bond, C, CH3, can it react with ammoniacal copper chloride? No. Why? It is non-terminal. So when are you terminal? When you have hydrogen CH, end, CH, can end, or CH here, end. What have I summarized? What am I saying so far? Alkane, alkene, alkyne, they are all hydrocarbons. Alkane, those ones they are saturated. What is you? So they will not even dechlorize bromine water. They will not react with ammoniacal copper chloride. That's why you call the alkane paraffin. What do I call them? Paraffin means little affinity. They can't react. Have you seen I told them in one of the classes, have you seen a very rich man praying before? So then they don't pray with, agonizing and jumping and screaming. See a rich man is touching his belly that is big, pot belly. Oh God, thank you for the 5 billion that just entered yesterday. I'm thanking you for the 4 billion that will enter tomorrow. Thank you, Jesus. In Jesus' name I pray. But someone who has not eaten for 2 days and is not fasting, his own prayer point will be different from that one. The alkanes and alkynes are unsaturated. They are very, very reactive. And most of their reaction is addition kind of reaction. But Mr. Alkane and alkyne, the two of them do unsaturated, but they have a distinguishing reaction we can use for them. That's the reaction with metallic. We call it metallic derivative. This one is sodium now. What will sodium do? Sodium will come and remove the hydrogen. So the hydrogen here is called acidic hydrogen. Why? It can be removed by metal. So what is the name of this compound now? Sodium. This is sodium. You start from sodium. Sodium. How many carbon do we have? 1, 2, 3. When you have 3 carbon, what is that? Prop. So that's sodium propanamide. What do I call it? That's it. Proper. That's it. So the answer is option what, class? Option what? Look at 44 now. Option C. I've given you the equation. See it on the board now. Sodium will remove the hydrogen. That's all. The hydrogen gas. But the major product they're asking for is that P. They say, what is P? This is P. The answer is C. Oh, yeah. We go to number 45. If you don't have question, come and pick question. I'm sure the online students are following. Okay. 45. The label on a reagent bottle containing a clear organic liquid dropped off. The liquid was neutral to litmus and give a colorless gas with metallic sodium. The liquid must be an... See, when you're solving question, you must learn how to get answer even without knowing it before. Now, when you talk about liquid, alkanoate is option A. Mr. Adams, what's the formula of alkanoate? Alkanoate are esters. And Amos has given you those, table. Alkanoate, this is their formula. RCOOR prime. That's alkanoates. Esters. They have sweet fragrance. They have sweet smell. That's why anywhere you see ester around you, the place always smelling nice. The ester, they have good fragrance. Sweet smell, odor, aroma. That's alkanoate, ester. Then B. What's B? Like people don't have question. What's B? Alkene. Alkene is CnH2n. What's C? Alkanols. What's alkanols? CnOH. And what's D? I can't hear you. Cn. Look at this. Number one, they mention what? They mention liquid. Mr. Alkene cannot be liquid. Alkene cannot be liquid. Except the petroleum products like petrol, kerosene, and that. So those guys, number one, we are disqualified. You're not liquids. That's one. Number two, reacting with metal. How can this one react with metal? Especially this one. These guys are not reactive at all. They are paraffin. They don't even undergo reaction. So alkanes totally out. Alkanes also cannot react with metal. But I'm happy you know something. They didn't mention alkyne. I hope you know. Look at them. Why did they mention alkyne? Alkane can react with metal. What type of alkane can react with metal? Terminal alkynes. I'm happy some people are learning. Now, this one here with metal. Where is the hydrogen you are going to replace? There is no hydrogen. There is no hydrogen here. But this one here, this is ROH. This is another way of writing alkanol. ROH plus metal. Look at metal. There's possibility. Sodium will remove this one. And the hydrogen will be disappeared. So you're going to have RONA plus what? Look at them. What is the name of this thing I've written? RONA. Raise your hand. Be guessing, be trying. You just sit down like that's the reason why you are in the main class. You are here. You have access to question, answering questions, see me face to face. Trying question. Who want to try? Yes. Eh? Yes, Nancy. Nancy, you've been flashing me and calling me since yesterday. You missed me or what? Sodium ester. No. Ester. There is no CL. Yes. AY. Alkyl oxosodium. Beautiful nonsense. Yes, who want to try? Sodium. Abad. Alkali. Abide. Are you an herbalist? Esther. Sodamide. Nothing like that. Amide, but don't say alkine. This is not alkine, no. Ethamite call. Ethamite, yes. Methoxysodium. I love you for that. Try guesswork, but it's wrong. Yes. Sodium alkoxide. Thank you. Sodium alkoxide. Sodium alkoxide. Oh yeah, let me now attempt to now. We now have ethanol. Let's do this ethanol now. Plus sodium. Now, come on, come down. Yes, sir. Now C2H5ONA plus what class? What type of reaction is this one? Displacement reaction. Oh yeah, what will not be the name of this one? Say this one, we don't say rubbish. Oh. This is sodium alkoxide. What is one will not be? Sodium alkoxide. You want to raise your hand? Shut up. Who want to talk? Yes. Angel. Etoxide. That's a beautiful angel. This sodium etoxide. This is ethanol now. If this is alkoxide, then the sodium etoxide. Thank you, dear. Etoxide from ethanol. Sodium etoxide. That's it, sodium etoxide. Class, what's the answer now? Alkanol. Alkanol. Hydrogen can be replaced by sodium. Alkanol. Look at number 46 now. Be jotting down point too. Okay. Some people have almost jotted down 3 pages of notes. I'm serious. Some people are lazy. They cannot jot. Waiting for dictation. Now, before I solve this question, Aisha, what's the name of this compound? Ethanoic acid. Good. Just me. What's the name of this compound? Ara. What's the name of this compound? Ethane dioic acid. Yeah, 2 carbon atoms. 1, 2. That will be 8. Ethane dioic acid. So how do you get ethane? There are two carbon. Now, another that said ethanoic. See, this is ethanoic. Ethanoic is having only one COH. Because you're now having two COH, you're now having dioic. That means two COH. What about the ethane? Two carbon. What about the dioic? Because two COH. But this one is ethanoic. One. Ethane dioic acid. Oh yeah, plus what class? Sodium hydroxide. Can't give us COOH, CONA. That compound also has a very old name. That's an old name. It's called oxalic acid. H2C2O4. Oxalic. That's the old common name. For sure. What's the answer to that question? The entire answer. Neutralization reaction. But this is an acid. See, ethane dioic acid is acid. This is a base. This is salt and water. So the answer is neutralization reaction. There's nothing displacement there. There's nothing elimination there. So what about saponification? Yeah, that's the process of manufacturing what? Soap. It's called alkaline hydrolysis of ester or alkanoids. Okay, now so we move on to 47. Alkanoic acid have low volatility. Now, when you have low volatility, Ego, that's the name of it. Okay, I reverse your name. Ego, okay. Reverse reaction. Okay. When you say something has a low volatility, what does that mean? When something has low volatility, what does it mean? Daniel, what does it mean when something has low volatility? Yeah, it will not vaporize easily. That means it has high boiling points. That's the word. So when you have low volatility, it means you have high boiling point. Be noting it, will be looking at me. You have high boiling point. Let's now look at the answer. They said alkanoic acid have low volatility. That means they have higher boiling point. Compare with alkanol because they are more polar than alkanols. They have two oxygen atoms, while alkanol have one. They form hydrogen bonds, while alkanols do not. They form two hydrogen bonds, while alkanols form one. What's the answer? If you think the answer is A, raise your hand. Let me see. Okay. You think the answer is B, raise your hand. You think the answer is C, raise your hand. You think the answer is D, raise your hand. Raise it very well. Okay. I don't even know which one can be the answer. Raise your hand. Because majority of you did not raise your hand. Raise your hand. Okay. I'm always happy when people are truthful. Alkanols, alkanoic acid have low volatility. Low volatility means you have high boiling points. And one of the characteristics of compound that have high boiling points is that they are highly polar. So that's why it's A. All of you did not get it. Only 3 people raise hands. Yours were picking D. Form 2 hydrogen bonds. Why I cannot form 1? Why? Why did you form the 2 hydrogen bonds? Let me show you the structure. Structure for alkanoic acid. Alkanoic acid is RC, double bond O, OH. Then alkanol, ROH. So there's no double bond. This is OH. That's hydrogen bond. This is hydrogen bond. But they both have hydrogen bond. This one does not form any two. The reason why this one is polar is because this is theta minus. Oxygen will pull electron towards itself. Pull electron. This one becomes theta plus. We call it polarization. So this guy here is more polar than this one. Right, note everybody. The higher the polarity of a compound, the higher the polarity of a compound, the greater its boiling point, The higher the polarity of a compound, the greater its boiling point. The higher the polarity of a compound, the greater its boiling point. The higher the polarity of a compound, the greater its boiling point. The greater its boiling point. So that's that. 48. Have you been taught petroleum? No. So you have a lot of work to do. 41 days to the exam. Don't wait for your teacher. So read. (41) 48. The octane number of a fuel whose performance is the same as that of measure 55 gram of and 55 gram of N-heptane is what? Now look up. When you buy petrol, your petrol is obtained from the fractional distillation of petroleum. Another word for petroleum is crude oil. That crude oil cannot be used because it is crude. So you have to allow it to carry out, do fractional distillation. And that guy has more than 2,000 products. That's why Nigeria, our major problem in this crop, apart from corruption, poor leadership, is our discovery of petroleum. When we discovered petroleum in Nigeria, we now went to rest. We stopped developing other infrastructure. We stopped farming. Farming became unattractive. Nigeria was one of the highest producers of palm oil in the world before. Then a country called Malaysia came to Nigeria and we taught them how to produce palm oil. They went from Nigeria with one seed of palm oil. Today, Malaysia is one of the leading producers of palm oil in the whole world. They are beating Nigeria. And we taught them how to plant palm oil. Nigeria we have a cocoa house in Ibadan, one of the biggest ever. We are one of the largest cocoa producing country in the world. But because we discovered petroleum and money was coming from there, we became lazy. That's why agriculture is no longer attractive in Nigeria. And that's a pain to all of us. Now, if you can get petrol from fractional distillation of petroleum, listen. Your petrol can also cause what they call knocking. The engine can knock very easily. If it contains straight chain petrol, if it contains what? Those ones they cause knocking very fast. Knocking. Straight chain petrol causes knocking. But branched chain petrol are better. Knocking. Straight chain petrol. Straight chain petrol. Who are they? Number one, N-heptane. That's one. The guy can cause knocking like mad. Another one, N-octane. Then good petrol. Good petrol is what? Branched chain. Branched chain petrol. Mr. Hasdan, can you give us branched chain petrol? 224 trimethylpentane. That's the one they gave you now. 224 trimethylpentane. So, if your petrol contains 224 trimethylpentane, is it a good petrol or bad petrol? If your petrol contains N-heptane, is it good or bad? N-octane, good or bad? Bad. They make the engine of a car to knock. What are the scientists now doing? They are now doing what they call anti-knock. They will add anti-knock additive. Anti-knock what? They will add it to your petrol. Say, your petrol. So your engine will not knock. Make it add something. Make it top arm with something. They will not add something. That thing they are adding to prevent knocking. It's called what? Somebody anti-knock additive. And one of them is lead tetraethyl. Lead tetra what? Also, I want to dibromoethane, but this one is a major one. But look, listen to me. This one now is now more dangerous. Why? If your car knock, you can still buy another car. But if you go and inhale lead, you yourself that owns the car will now knock. Because this thing, if it is exhausted from your exhaust, and you inhale it, you are going to be inhaling lead poison. Inhaling what? That's the danger of this anti-knock. How many of you are always buying akara on the road? You are in danger. Yes, akara. See that one, the way she's looking at me is that, what are you talking about? Yes, the truth. Yes. Buying akara, yam, yeah, plantain. Especially one that is not covered. Those exhausts can contain lead of the cars that is passing. And once you eat them, you are on the verge of dying. Have we not heard of people dying before because they put their generator in their house, in their shop? They are living in the shop. Poverty. Living in the shop, and you don't want them to steal the generator. They put the petrol inside the shop and they slept there. And they cover everything. A man for I think 7 of them died that morning. The whole family wept up. Why? Because of the inhaled lead poison from the exhaust of the petrol. That one is not ordinary carbon dioxide. Lead poison is there. So be very careful. That's it. Class, what type of petrol can cause knocking? I can't tell you. Examples are what? N-heptane. What is a better petrol product? 2,2,4 or branching. That's it. If I want to prevent knocking, what should I add to my something? And popular example is what? What is the danger of lead tetraethyl? Lead poison. Go to pass when we see all these things we are doing. They are there. Oh yeah, now, how do you now find octane rating? Oh yeah, look at the formula. That's what they say we should find. Octane rating equals value of ISO, value of this rubbish now. I don't want to write the whole story. Branching petrol, BCP. Value of branching petrol. That's this guy. All over total value. That's 100. So what is BCP? Branching petrol. All over total value. That's 100. Let's go now. Branching petrol. How much? How many? How much is that? 2,2,4 trimethylpentane. How much is that? So you have 55. Total value. We now add 55 plus that N-heptane. That's what? Answer will now be what? 55 over 100. What's the answer now? That's the answer. Octane rating. Value of branching petrol over total value times 100. Let's go. Next question. Number what now? So the following is formed. Yes, I was going to give you fine. Just let's continue. Sorry. So the following is formed when maltose react with concentrated tetraoxosulfate 6 acid. Class, look up. Conc H2SO4. Have you been taught sulfur and its compound? No. So consider you have a lot of things to read. Making a no read. Conc H2SO4 is a powerful dehydrating agent. Powerful what, class? Dehydrating agents are those substances that can remove water from you. They can remove what from you? Can remove water. So if you have water, water come out. Look at an example. C2H5OH. You can't use conc H2SO4. What would the guy do? He'll say, can I get water here? Okay, one hydrogen, come here. One OH, come here. We'll remove water. And we are going to have C2H4, 18. This is ethanol. We have removed water. See water. Hydrogen and OH is water. And this is 18. Then I can have maltose. Maltose now members of the disaccharide. C12, H22, 11. I beg, come over here. Yes, sir. Class, what do you think, Mr. Before we want to remove? What is he removing? He's going to remove this water. If he remove 11 water from you, what will now be left? Carbon. That's the answer. Charcoal. 12 carbon. That's it. That's it. The same thing apply to sucrose. This maltose now. Maltose. This charcoal. I can also have COH. COH. I was giving you Utme. That's ethane. 1,2 what? Dioic acid. Class. If I remove water from this compound, what am I going to have? Remove water. How do we remove that? See water. H and OH. Abi now. What we left on top? CO. That's CO2. Abi. What will be left below? CO. What are the questions they can ask you? Is that Elizabeth? That's my girl there, day student. She's here. Some people are still at home. Look at that. Oh yeah, start answering this question now. The function of conc H2SO4 in the conversion of ethanol to ethene is what? Dehydration. Dehydration. The dehydration of maltose will finally give us what? Charcoal. What compound is used in the dehydration of ethanol? Conc H2SO4. I'm giving varieties of the way the question can come. Yeah, Lawal, you are in class. Good. Moise, you couldn't connect. Thank God you are in class. So the answer to that question is charcoal. Have you now? Charcoal. Which of the following compound represent the preliminary product of ethyne? Or I'll give you a fun. Class, what's the formula for ethyne? C2H2. Ethyne. Polymerized. You're going to use what they call organonickel catalyst. What do I call it? Organonickel catalyst. This guy will undergo polymerization. You need 3 molecules of it. You now give you a popular compound called benzene. Called what? Benzene. Benzene. Very popular organic liquid. This ethyne. So when they ask you, when ethyne is polymerized, what will it give you? Benzene. That ethyne is called monomer. It's called what? Benzene is called what? Polymer. Polymer means compound obtained by combining 2 or more compounds. So this is benzene. This is ethyne. And benzene can be drawn like this. Because benzene has double bond. That's why you won't just leave it like this. This is cyclohexane. Because it's benzene, you can put something like this. Alternated. That's calculate structure. So you alternate it. Either you put it here, here, here. Because benzene can undergo resonance image. So the answer is A or B? A. We took many hours to solve 10 questions so I can learn something. At the end of the day today, I'm going to be asking you questions from what I've taught you today. I won't come to the ground floor because there's no way microphone will get there. I can come, but I'm going to stay here. So all of you that are here, I can just come to you and ask you things that I've taught you. So I don't want to hear, I don't know chemistry. That's why we spend 2 hours answering, 1.5 hours answering 10 questions. Let's go now, everybody. Now, question 1 to 10. That's what you have known now, all those simple parts. You have 5 minutes. Your time now. Cheaters, give them fun before they kill me. Those people are looking at me and saying, Adams, you are wicked. If you don't have question, come and collect question. Just give them question. Come and collect at the front. You have 5 minutes. Do it as if you are doing an exam. For your 1 to 10. Are we true? Or you didn't 1 to 10? Sorry. Number one, this part are not difficult now, so we won't spend much time because you've been taught. And there are basic things you know in chemistry. What the following is a physical change. When you talk about physical change, we are referring to a change that is reversible. You know, physical change are reversible. Reversible. Our water now in ice block, solid form, and then it turns to liquid. Ordinary water. This ice, this water. Water turns to ice. Ice can also turn back to water. Water can turn to ice in that order. So it's a reversible reaction. So this is a physical change. If I boil it, It turns to vapor. The vapor can condense back to liquid and all that. So physical change is reversible. No new product is formed in physical change. So the secondary falling is a physical change. The bubbling of chlorine into water, of course, that's a chemical change. Chlorine into water will give you new product are formed, osochlorate, 1 acid, and ACl. So that's a chemical change. New product are formed. Bubbling of, okay, the bubbling of chlorine to water, bubbling of chlorine to a jar containing hydrogen. Chlorine, can't add them to hydrogen. You're going to have a new product, hydrogen chloride, ACl. So no product is formed. This is water, no new thing is formed. And that one is not reversible. You cannot break ACl into chlorine and hydrogen. Then C, dissolving of sodium chloride in water. That's the answer. But dissolve sodium chloride in water. I'm going to have sodium chloride solution, aqueous. And I can separate it. I can still get my sodium chloride back, through evaporation. If I apply it, the water will jump away. I can get my sodium chloride. So the answer is C. Passing of steam over heated iron. That's a chemical change. You're going to have to try iron tetraoxide, new product. So C is the answer. Number 2, changes in the physical state of a chemical substance T as shown. And they say what is X? S is solid to gas. When a solid turns to gas, you said the solid are sublime. That's sublimation for the first one. Sublimation. Then Y, from gaseous to liquid. Gas to liquid. That's when I go condensation. Condense. Gas turn to liquid. Where is Ojo Deborah? She has what? She went home. Then the last one is what? Liquid to solid. Freezing. 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 If we don't see freezing, can choose another word. So the answer will be A, Abby. Then the reaction, have you taught stoichiometry? That's much work. So you don't know calculation in chemistry. So you have tin 4 oxide plus. You don't be waiting for a teacher. We have to read ahead. So they will still do those things, but where we start knowing them now. Tin 4 oxide plus carbon give us tin and carbon 2 oxide. The mass of coke containing 80% carbon required to reduce 0.302 kilogram of pure tin oxide is what? The mass of what? Mass of coke. This one. So this is what we are talking about. And then they mentioned 0.302 kilogram of pure tin oxide. So we're concerned with only these two guys. They mentioned coke, that's a C. They mentioned tin 4 oxide, this one. So all this one is not our business. Now, what are you going to do? Find the molar masses. From there, the answer is solved. Well, let's find molar mass. What is tin? How much? 119. What's oxygen? 32. Add the two. Then what are you going to have? 151 gram. Then carbon. That's 2. Times 12. What's times 12? 24 gram. Look up. There's no big deal here. So how do you get 151? Just add. Tin is 119. You are given. Oxygen 16 times 2, 32. You add these two now, you have 151. Carbon 2 times 12, 24. So they now give us to reduce 0.302 kilogram of pure tin oxide. So they give us 302. Convert it to gram. That 0.302 kilogram is 302 gram. 1,000 gram make 1 kilogram. This one will now be X. So how do you get 302? Is in the question. Look at it. 0.302. Like 151x. That will be 302 times what class? 24. So our X now will be what? 302 times 24 over what? 151. So what's your X? 48 gram. So what is 48 gram? That's the mass of carbon there. But look at the question. They said containing 80% carbon. The mass of coke containing 80% carbon. So we're going to have 80%. The mass of coke, 80% carbon. So 80% of X is 48 gram. I will explain. 8X will now be 48 times 10. 8X will now be how much? 480 gram. So our X now be what? 480 over what? 8. How much is that? 60 gram. But if we want the answer in kilogram, that will be 0.06 kg. So 80% of this one now will be 48 gram. I will explain to you. It's not difficult at all. You don't need anyone to teach you this. Tin, 119. Oxygen times 2, 32. Then 2 times 12, 24. So 151 gram is 24 gram. 302 gram is unknown. So how do you get 302? I will have even left it in kilogram. But no big deal. So that's like 48 gram. But that's not what they want us to find. That 48 gram is 80% of something. So 80% of that coke is 48. So we're looking for the mass of coke. That will be 0.06 kg. Number 4. The Avogadro's number of 24 gram of magnesium is the same as that of Avogadro's law ló sọ wípé equal at the same temperature and pressure contain the same. Again, Avogadro's law ló sọ wípé equal volume of all gases at the same temperature and pressure contain the same number. Thank you. So consider that Avogadro's number is all about the fact that if we have the same mole, we should have the same volume. The Avogadro number of 24 gram of magnesium. The number of mole of magnesium is what? Mass over for magnesium. Number of moles. Number of moles is mass over atomic mass. Mass over atomic mass. So what's mass of magnesium, class? What's mass? I can't hear you. What's atomic mass? 24. What would that give us? 1 mole. So now go and look for all the answer that will give you the same number of mole, which is 1, 1. Let's go to option A. What's option A? Hydrogen is what? 2 IB. 1 times 2, that's 2 grams. So when I say 1 gram, number of mole, you're not supposed to start working this zone. Number of mole will not be. How many grams are you given? 1. So that's 1 over 2. So that'll be 0.5 moles. So that's wrong. We're looking for the one that will give us 1 mole. Go to B. What's B? Oxygen, 16 grams. Number of moles also. That'll be 16 for oxygen over 32. Are we? See oxygen here, 32. That's 0.5. That's also wrong. What's C? That's the answer, are we? 32 grams. So number of moles. That'll be 32 over 32. That's 1 mole. So I won't waste time. The answer is C. They're asking for the one that has the same number of moles. Number 5. Start improving, start learning. They will call learning by induction. We don't have enough time to cover the entire syllabus for yourself. But with this one now, we are covering. This is the whole syllabus now that I'm holding in my hand for chemistry. Number 5, number 6, or 5. If a gas occupies a container, volume V1, 146, this is gas law. At 18, that's temperature 1. What's 18? 18 plus what? Add it 12, then what do you get? 291 Kelvin. Pressure 1, what's pressure 1? 0.971 atmosphere, Abby. What are we looking for? Volume V2 at what? What temperature 2 at STP? What's pressure 2 at STP? 1 atmosphere. 760 millimeter mercury, 1 atmosphere. So we have P1 V1 over what? P2 V2 over T2. So we're going to have P1. What's P1? 0.971. What's V1? 146. Temperature 1? 291. Pressure 2? 1. Volume 2? Unknown. Temperature 2? So we're having 291 and V2, 273 equals 0.971 times 146 times 273. Therefore, our V2, what will they give us? 0.971 times 146 times 273 all over 291. What's the answer? 133. Is it there? Very good. So you should be knowing, you should be getting all these Charles law, Boyle's law yourself. Number what now? Number 6. The volume occupied by 1.58 gram of a mass. This. Now, number of moles. Number of moles is always mass over molar mass. And that's also volume over gram molar volume. Mass over molar mass. We also have volume over gram molar volume. Mass over molar mass. All right, let's go now. What's mass we are given? 1.58. Molar mass, call it X. How much volume are we given? 500. What of gram molar volume? 22,400. You'll be having 500X at 1.58. That's 22,400. Our X now will be 1.58 times 22,400 all over 500. Calculator, what do you get? 71. Very good. That's chlorine, Abby. 71. Option D. So number of mole is mass over molar mass or volume over gram molar volume. Number 7. Equal volume of CO. What does you find the molar masses of each of them? Carbon 12, oxygen 16, giving us 28. Next guy, SO2. Sulfur 32, oxygen 32, giving us 64. Next guy, NO2. Nitrogen 14, oxygen 32, giving us what? 46. Last guy, hydrogen sulfide. Hydrogen 2, sulfur 32, giving us. What did they say we should do? Which of the following gives the order of diffusion? Order of diffusion means from the slowest to the what? Fastest. The bigger you are, the slower your rate of diffusion. That's Graham's law. The rate of diffusion is inversely proportional to the square root of your vapor density or molar mass. So if you are too big, you can't move very fast. So this guy has the smallest mass. It will have the highest rate of diffusion. Followed by this one. So this is going to be first, highest, second, third, fourth. And we have to start from SO2. Abi now? You must start from SO2. The fastest. Followed by what class? NO2. Followed by what? H2S. And the fastest is who? CO. Option what? So you have to look for the one that has a heaviest mass, and then you go. Number 8. Number 8. A basic postulate of the kinetic theory of gases is that the molecules of the gas move in a straight line between collision. This implies what? Collision is perfectly elastic. Force of repulsion exists. Force of repulsion and attraction are in equilibrium. Collision are inelastic. The answer is what? A. Collisions are perfectly elastic. What does that mean? Energy is what? Conserved. Momentum is also conserved. Then number 9. P, Q, R, and S. Proton, electron, neutron. Which of the 4 atoms, P, Q, R, and S in the above can be described by the following property? Relative atomic mass is greater than 30, but less than 40. What is relative atomic mass? That's the what? Number of proton plus number of what? Neutron. So if you look at, and they said that's an odd atomic number and forms a unipositive ion. Odd atomic number. Then it can be P, Abi, because 13 plus 14 is 27. But it is greater than 30, but less than 40. Put your mind in this thing. Be checking. Hey. Then they said it has an odd atomic number. So it can be Q, Abi. Mr. R, that neutron is not 35. Oh. Neutron should definitely be 18. 17, 17, 18. That Mr. R. 17, 17, 18. So when you add those two together, 17 plus 18 is what? 35. Which is more than 30, less than 40, Abi. And they also say it has what? A unipositive ion. That means you are going to lose electron. Mr. R cannot lose electron. Do you know that? Because if it loses, it has to gain one, like chlorine. So the answer is S. Is it S? 19 plus 20 is what? 39. More than 30, less than 40. And then 19 is 288. 288. The guy can lose one electron. So it's unipositive. Don't pass any question by. Make sure you learn it, know it. This is not the time for cramming. Number 10. What are the following terms indicate the number of bonds that can be formed by an atom? Oxidation number, valence, atomic number, electronegativity. What's the answer? Who taught you that? They must taught you that valence is what we use to know type of bond. What are the following terms indicate the number of? It is the type of bond, the number of bonds. Type of bond, valence. How many electrons do I have in an atom's shell will determine type of bond, not number of bonds. Look at that word. So don't get it wrong. Type of bonds. Type of bonds. That's valence. What does that mean? How many electrons do I have in my outermost class? If I have 281, what's my valence electron? 1. What about bond? What type of bond can I form? Electrovalent or ionic? Abi? Why? I can easily lose. If I have 287, how many valence electron do I have? I can easily lose what? 7. I can easily what? Gain. I can lose 7. Gain electron. That's also ionic bond. So what determines your type of bond is your valence electron. What determines the number of bonds is your what? Oxidation number. You know, oxidation number of bonds. Please note it too. Type, valence, number of bonds, oxidation number, ON, number of bonds. How many bonds can you form? How many? So that's depending on your oxidation number. That's why you can see that many of the words transition element, they have variable oxidation state. And because they have that, they can form many types of bond. They can form many number of bonds. That is it. Some of them, like Mr. Ion, for example. Ion can be ion 2, can be ion 3. Can have chromium 2, chromium 3, chromium 6. They have different oxidation states. I mean, they have different number of bonds. Please take notes. Okay, now, so let's do number 21 to 30. You have 5 minutes. Let's get them fun. 21 to 30. Don't say I'm tired. We are just starting, We never start physics, 21 to 30. That 21, those online and on YouTube. What volume of 1 molar? That's not 11. 1 molar, not 11. What volume of 1 molar? 1. Just try. Don't wait for the correction. Try as if you are doing an exam. What volume of 1 molar? The hostel students should never miss 22 and 23 because I've solved it for you before. Somebody was asking about 7. Why did we start from sulfur oxide? One is said order. I'm referring to how from the smallest to the biggest now. Arrange the student score in the order. I mean from the lowest score to the highest. So SO2 has the lowest rate of diffusion. Why? It has the biggest mass. So from the lowest rate of diffusion to the highest rate of diffusion. So start from the one that has the highest molecular mass to the one that has lowest. You have been through by now. 21 to 25. So why is the order of diffusion starting from the largest? You are all asking the same question. We didn't start the order of diffusion from the largest. We started the order of diffusion from the lowest diffusion. The lowest diffusion is SO2. We started from that guy because it has the biggest mass. When you have the biggest mass, you have the lowest rate of diffusion. Some people are true. Some people put their heads down. They're tired. They're not thinking anymore. Adams will give us answer. So is N-pentane is rich in petrol. Pentane is not a petrol. Petrol starts from majorly 6 carbon to 9. Pentane is just like, people call it petrol also, but it's not a good petrol. At least 7 and 8 are the petrol. Heptane, octane. Okay, 21. Please, I want that fan again switched off. I can hear myself. Sorry. Thank you. What volume of 1 molar hydrochloric acid must be diluted to obtain 1 dm cube of this? That's called principle of dilution. Principle of dilution. We dilute substances in order to reduce their what? Concentration or increase their volume. You know. Most of the acid in laboratory in the secondary schools have been diluted so that students, if they mistakenly put it in the pipette and draw, they will not die eventually. You know, to be a dilute acid. And again, for you to go around, for example, I want to do practical in Adams College now. See how many we are. We are going to buy maybe 1 bottle that is too concentrated. What will I do? I will turn that 1 bottle to 1 drum. I will pour it in a drum and then stir. The aim at that period is not to reduce corrosivity or the danger effect, is to ensure that you can go around. So we dilute substances to increase the volume or to probably reduce the concentration. So C1V1, the initial, what volume? The concentration is 1, so you put 1 here. So our V1 is unknown. Then our C2, what's that C2? 0.05. That's a new concentration. You can see it has been diluted from 1 to 0.05. What's the new volume? 1. So our V1 will be 0.05. Is that the answer? That's the answer. 0.05 dm cube. Option A. 22. If 10.8 grams of silver is deposited in a silver colorimeter connected in series with a copper colorimeter, the volume of oxygen liberated is what? Now, the hostel students have been taught all these things because we did electrolysis fully. We solved about 40 questions one of the weekends. So we are talking about silver and oxygen. So it's a number of mole of silver all over number of mole of oxygen equal charge, you can use Z on oxygen over charge on silver. That's second law. Your teacher will still teach you too. That's it. Number of mole of silver over number of mole of oxygen. Charge on silver over charge on oxygen. Number of mole of silver is mass of silver over atomic mass of silver. Number of mole of oxygen is volume, because the oxygen is a gas. Volume of oxygen over gram molar volume. Now, charge on oxygen is 4. The silver is 1. So how do you get 4? Anytime oxygen is liberated, this is always a reaction that led to that. 4 hydroxy will give us 2 water molecules plus oxygen plus 4 electrons. That's it. So we need 4 moles of electron. Or if it is not clear, O is 2 minus. And then oxygen in diatomic form, we need 4 of these. So I'm going to have minus, that's 4. Then silver is always plus 1. What's the mass of the silver liberated? 10.8. Silver is always 108. Divided by the volume we're looking for is unknown. The gram molar volume is in dm cube. There are some hostel students that didn't solve this question. Why? Because we solved it that day and they remember it now. That's the essence of revision. I saw this before. I think the answer is 5.6 or 0.56 or something. You can get it. So I want to have 4 over 1. They only solve it to confirm. 10.8 here 1 here 10. So you have 1 over 10. That's 22.4. All over V is 4. Then we have 40 V is 22.4. So our V now be 22.4. All over 40. Then I have 0.56. There. What is the aim of this revision? If you see something like this tomorrow or in the exam anytime, you should be able to get it. Not the same story. I hate chemistry. I want to study medicine. Can you be shouting? So since you hate the subject, what are you doing to learn it? So start changing your language. 23. 0.1 Farad of electricity deposited 2.95 grams of nickel during electrolysis of an aqueous solution. Calculate the number of moles of nickel that will be deposited by what? 0.4 Faraday. Calculate the number of moles. They're asking for number of moles. So everybody know a number of moles. Okay, maybe I should just do it this way. So we don't waste time. Now, this is the same nickel. You can just use direct relationship. It's nickel. Unlike this one is silver and oxygen. Second law. This is nickel and nickel. So 0. I can just say, I beg 0.1 Faraday. 0.1, waiting. Is it Faraday? 0.1 Faraday gave us how many? 2.95 grams. Then 0.4 Faraday. Because it's the same nickel. X. We're going to have 0.1 X. 0.4. That's 2.95. So our X now be 0.4. That's 2.95 all over 0.1. Calculator, what do you get? 11.8 grams. But they're asking for number of moles. That's it. Therefore, number of moles. Number of moles is mass over what? Molar mass or atomic mass, because atomic mass. So that'll be 11.8. What atomic mass of nickel? 58 points. Oh yeah, divide, what do you get? 0.20 moles. That's the answer. 24. In the above equation, where is Jade? Okay. Are you getting it? 24. In the above equation, the original number of chromium changing from, we should get that as redox reaction. There are some students from the hostel that are still at home till now, since last upper Thursday. Still at home. Still at home. Why are you not in class? I'm doing Jamb mock. Jamb mock for 7 days and they are still not around. And some of them are struggling with all these subjects. 24. In the above equation, there's a number of chromium. Chromium is Cr2O7 on the left. 2 minus. Let's find it. Chromium, that's 2 times X. This one here. Oxygen, minus 2 times 7 equals what? Minus 2. So we're going to have 2X minus 14 equals minus 2. So we have 2X will now be what? 14 minus 2. 2X will be how much? 12. Our X will now be what? 12 over 2. So what's your X now? Plus 6. Plus 6. Similarly, we're having what again? On the right. 2. So the guy turned from plus 6 to plus 3, are we? Plus 6 to plus 3. So then we ask for change. Change will be final value minus the initial. If they're asking for change, now that'll be 3 minus 6. Answer would now be what? -3. Change. But they're not asking for change. So that's the answer. +6 to +3. That's 25. I've answered it before for medical students here. The iodates. IO3 minus. The 5. This is iodide. It's hydrogen ion. 3 iodine plus water. This type of reaction is the easiest ever. When they say, what is your oxidizing agent? I don't even check my own schedule to get answer. I don't have to blink. Because they have rules, simple rules. What's the oxidizing agent? What's the reducing agent? Who is oxidized? Who is reduced? I know they waste time. And why won't I waste time? I've told you, see. I listed the other time for you, oxidizing agents, popular ones. And I said all the fluorine in this world, all the chlorine in this world, all the bromine in this world, all the iodine in this world, all the Cr2O7, all the K2Cr2O7. The popular one, I'm not writing all, KMNO4. These are popular words. Once I see them, I don't waste my time. And if you don't see them on the left, you see them on the right. They're reducing agents. You just turn them to all the F minus, all the Cl minus, all the Br minus. I know they read all these things, all the iodide, and of course the hydrogen sulfide of this world. I don't need all of them. These ones are enough to answer 10 questions in your pack. This is just table. Look at the question. What's the question? Then the reaction. Oxidizing agent is, I'll just go to the answer can never be from the right. So someone that pick option D, you are terribly wrong. That doesn't make sense. Your answer can never be on the right. And your answer can never be hydrogen ion. This is just the acidic medium that the reaction took place. So I left with only 2 guys. So it can't be hydrogen ion. Right. Anytime you see the halide, you call them the halide. Halide. Anytime you see them, they are always reducing agents. Why, sir? Because reducing agent will undergo what? Oxidation. What's oxidation? Electron loss. They have gained before, they now want to lose it. So anytime you see minus, they are reducing agent. So without me solving question, I don't know about you. Uncle, I don't know you. But I know that you are reducing agent. I know you. So once you are reducing agent, this one you are what class? That's the answer. So anytime you see any of these guys, they are reducing. But if they appear on the left in this molecular form, they are oxidizing. I don't even need to know many things. These are enough. Check this 4. 1, 2, 3, 4. Go and check many past questions. Not because I cannot analyze, I can analyze. How do I analyze? Number 1, this one, you supply oxygen to this guy. You supply oxygen to Mr. Hydrogen, you turn it to water. So you are oxidizing agent. When you give me oxygen, you are oxidizing agent. When you remove oxygen from me, you are reducing agent. This guy remove oxygen from me. I say, oxygen, get out from that place. Yes, sir. You are the reducing agent. You remove oxygen from me. If I give you oxygen, I am the oxidizing agent. If you remove oxygen from me, you are the reducing agent. Look at this one. Let me ask a question. So what about if there is no fluorine halogen? And look at this. Water gas. Carbon get oxygen. Carbon no get before. This one has. This one supply oxygen to me. What's the name of this guy? If I give you oxygen, I am oxidizing agent. If you remove oxygen from me, you are what? So in this reaction, what's your coke? Reducing. What's your water? That's it. It's simple. Look at this one. Let me tempt you now. SO2 plus oxygen. Come give us SO3. Who is the reducing agent? Who is the oxidizing agent? O2. That's it. You know, if you give me oxygen, you're oxidizing agent. If I take it from you, I am the reducing agent. So you are the one that give me oxygen. You give your life to me. I become your sunshine. And then that's it. Everything. I didn't balance it too. Everything. So when you give me oxygen, you are the oxidizing agent. If I take it from you, I am the what? So that's that. I'm giving you a simple way of getting answer. So people now are doing okay, they are tired. They are watching Man U and Chelsea, Madrid and Barca from 1:30 p.m. till 9 after La Liga in the 9, 11. They won't be tired though. But now, tired. I've not even started. But I'm still going to do physics. I cannot do anything until I'm through. If it is 5, no problem. If it is 7 p.m., I'm here. And I'm still thinking of doing mass tomorrow, Sunday. My questions are ready. You must gain admission by all means. So that I will know I've done my own. We don't do anything. My brother for wedding is in the car. The bride can wait. Okay, we move to the next question. 26. Enthalpy change, delta H. Delta H is what? Each content of the product minus what? That's it too. Each content of the product minus each content of the reactant. The product here is what? Aluminum oxide. What's its value? Minus. Mr. Adams, there are 2 guys on the right now. Ion 2, they're there. That ion is in uncombined state. His own value will be 0. Ion not join anybody. It's alone, solo. So his value will be 0. Then the ion 3 oxide there, what's its value? Minus 822. So answer will have minus 1670 plus 822. What do you get? Is it there? Good. C. Ion galvanized. I shall be missing this one. I'll slap you. Ion galvanized with zinc is cathodically protected from corrosion. This is because zinc has a more positive oxidation potential than iron. Zinc has a less positive oxidation potential than iron. Claire, what is oxidation in chemistry? Process of electron gain or electron loss. Who would like to lose electron more? Is it zinc or iron? Who will be much interested in losing electron faster than the other one or more than the other one? Zinc or iron? Hey. It's zinc, No, it's iron. Okay. No. It's zinc. Yeah. Who would like to lose electron more between potassium and zinc? Who will be willing to lose electron? Potassium, Abi. Who will be willing to lose electron faster between sodium and tin? The same thing you have done. Where do you get those values from? From your electrochemical series. So you go back. Potassium we want to lose more, followed by sodium, followed by calcium, followed by magnesium, followed by aluminum, followed by zinc. That's the word. So zinc will like to lose more or easily than iron. Iron will now follow like that. So this one, the oxidation potential for zinc. Oxidation potential for zinc is 0.76 volts. 0.76 volts. Oxidation potential for iron is 0.44. Sometimes 0.45. For iron, 0.44. So what does that mean? That means Mr. Zinc has what? More or high positive potential than. That's the answer. So the answer is A. Zinc has a more. Sometimes this one is 0.44 sometimes. 0.45 volts, 4445. So Mr. Zinc would like to lose electron faster than iron, will be readily interested in losing electron. So the answer is A. Number 28. Number 28 is all about rate of reaction. Which of the following samples will react fastest? Now, there are so many factors that affect rate of reaction. One of them is temperature, Abby. Temperature. The higher the temperature, the greater the rate of. That's it. So when we want to make gari, eba, we now use ordinary water. We're not going to make gari eba now. That's something else, barium sulfate. You know, so the temperature must have to be high. The temperature is moderate, lukewarm. You won't get the eba very well. So you have to know that temperature must be high. Another one is the surface area. If you want the reaction to be very fast, what do? You turn it to powdery form. But for solid, these are the two major factors that you need. As catalyst. But in terms of reactivity, these two are very important. Because this one is external. You know, ground it very well and use a very high temperature. So let's go back to the question now. Which one has powdery form and higher temperature? Option D. 5 grams of powdered. Anything powder will be faster. And anything higher temperature will be faster. So that's a D. 29. In the reaction, two hydrogen iodide gas give us hydrogen plus iodine. Delta H 10 kilojoule. The concentration of iodine in the equilibrium mixture can be increased. What does that mean? We want to shift the equilibrium position to the right, Abby. We want to increase iodine. That means we are shifting it to the right. And the reaction, is it endothermic or exothermic? Endothermic reaction, do they absorb it or they lose it? Guys, give me more heat. I want it. And one of the way of moving it forward is to increase the what? Temperature. So raising the pressure is wrong. Pressure has no effect on this one because there are two molecules here and two molecules. So pressure has no effect. So don't pick pressure. So don't pick A. So if you raise the temperature, 30. So the following gases can be collected by the upward displacement of air. Upward displacement of air. It's also called downward delivery. Downward delivery. Your molecular mass, mm, your molar mass must be greater than 28. That's the answer. If your molar mass is higher than 28, then we can deliver you in that form. So what you do is that you go and look for the molar mass of each of them. You know, NO. NO is 14 and 16. That's 30 Abi. Then we have hydrogen. What's hydrogen? 2 Abi. What's the next one? Ammonia. Ammonia is what? 17. The last one, chlorine is what? 70 what? 71. So you can see that we have two answers there. But the biggest of them all is what? 71. So answer is chlorine. Why? It is much, much, much denser than air. That's it. Much denser than air. And let's go now. 31 to 40, 5 minutes. She give them. Some of these students have just returned to class. If you are just coming, you don't have question, please come for question. We have many questions here. I'm sorry for the challenge in the morning. The Zoom capacity was filled up. But so many people are connected online now on YouTube live. So you can also click on the link. So the following will liberate hydrogen from dilute HNO3. Answer is calcium. Calcium is very reactive, just like sodium. The upper you are in that series, the more reactive you are. Potassium is the most reactive, can liberate anything in the world from anybody. followed by sodium, calcium, magnesium. #31. The brown film given off, please switch off that thing. The brown film given off when 1005 acid is heated consists of. Now you expect to know some common gases. Like what's the color of chlorine? Greenish yellow. We don't know many, know some. What's the color of NO2? Reddish brown. Brown is okay. Reddish brown. What's the color of SO2? Purple. Yellow, colorless. But testing they fail. What's the color of ammonia? Colorless. So these are the two major colored gases. Two major color gases that we have. So and from now on, I can even answer that 31. The brown films given off when 1005 acid is heated consists of. Now, HNO3, if I heat it, what is likely thing going to happen? Because I'm going to have water. I'm going to have NO2. I also have oxygen. That's it. I think of balancing the equation. Maybe we put 2 here. We put 2 here. 2 hydrogen, 2 nitrogen, 6 oxygen, 4, 5, 6, 7. So you can put 2 here, maybe 4. Maybe 4. Maybe 2. And then 4. Hydrogen 4. Oxygen 2, 8, 12. That's it. So that's the equation. So the answer is NO2 and oxygen. Yeah, no NO2 only. You won't get ordinary NO2. This one is, what is the color of this one? Brown, Abby. Reddish brown. This is how much? What is this one? Colorless. Now, when brown and colorless are moving together, what are you going to see? That's the reason why oxygen is there. So not NO2 only. Is there anything that I got NO2 only? No. So the answer is nitrogen, 4 oxide, and what? Oxygen. The brown films given off. So what about the water? The water is not given up. It will be left behind. So the answer is NO2 and oxygen. These are the brown films. Consist of NO2. The water will be left behind in the base. So it's not going to be given up. So the answer is A. 32. So the following test will completely identify any one of sulfur. Look at that word. Completely identify any one. Completely identify any one of sulfur oxide, hydrogen, carbon 4 oxide, and nitrogen 2 oxide. Any one. Option A. Pass each gas into water and test with blue little paper. Class. What type of gas is sulfur oxide? Acidic. So when you pass into water and use little paper, you're going to turn from blue to what? Red. What type of gas is carbon 4 oxide? Acidic, the same thing, turn from blue to red. So if you pick A, you are wrong. Because you are going to be getting two different things, giving us the same effect, the same results. So looking for the one that can identify just one, that can identify one. So if you use that method now, we're not sure whether it is SO2, or what class? CO2. We're not sure. So we're having two of them giving us similar effects. Look at B now. Pass each gas into lime water. If you pass each gas into lime water, Mr. CO2 will give you what? A milky precipitate. That's very correct. But shockingly enough, SO2 will also give you a precipitate that is a bit white. So if you pick that one also, you'll be wrong. Yeah, you'll be wrong. So you are wrong. Then C now. Expose each gas to atmospheric air. If I expose sulfur oxide to atmospheric air, I'm going to have sulfur 6 oxide. I don't want to start writing equation. If I expose hydrogen to atmospheric air, I'm going to have H2O. If I expose carbon 4 oxide to atmospheric air, There will be no reaction. Class, if I expose nitrogen 2 oxide, that's NO, to atmospheric air, O2, what do you think we are going to get? NO2. NO2. And that NO2, what type of gas? What type of color gas is this one? Brown. So that's the answer. The answer is C. Yeah. That's the only one that will give you brown. If we do A, why is A wrong, Mr. Adams? Because if I put them into water and use litmus paper, there are two acidic gas there, SO2 and CO2. Two of them will give us similar effect. Blue paper will be turned to red. If I pass them into lime water, both SO2 and CO2 will dissolve. Of course, CO2 will give us, a chalky or milky precipitate. But SO2 will also give us H2SO3, which is also like a white precipitate as well. So that will make it difficult to pick only CO2. But we now expose all of them to oxygen. Only this one will give us the brown gas. And that means that because I'm getting brown gas, after exposing to oxygen, then the answer is NO. So the answer is C. And you see, you are missing many of them, but that's not my concern. My concern is just learn, and then note down some things in your notes. Some of you are lazy. The impression you are giving now is that you are tired. I'm not interested in your faces or your reaction. 33. In the Haber process, for the manufacture of ammonia, catalyst commonly used is finely divided words. Ion. In the contact process, what is the catalyst we use? Vanadium 5 oxide. So we use ion. Number 34. A metallic oxide which reacts with both HCl and sodium hydroxide. That means you can react with both HCl and sodium hydroxide. That means you're amphoteric, Abby. As amphoteric oxide. You have both acidic and basic property. Amphoteric oxide. What type of oxide is zinc oxide? What of aluminum oxide? What of sodium oxide? Basic. I don't want to say ampho it here. What of lead oxide? Amphoteric. What of sulfur oxide? What of nitrogen 2 oxide? Neutral. What of CO? What of N2O? Neutral. What of calcium oxide? Acidic. Acidic. What is that one? What of tin 4 oxide? What of lead oxide? Very good. Let's move. Number what now? The falling metal will liberate hydrogen from steam. Look at that word, from steam. From steam, or what? Dilute what? Everything again, go back to what? Go back to what, class? That is it. The most reactive one is the one that is what? Above. So don't just pick answer anyhow. Look at this. Anybody below me can never displace me. You can't chance me if you are below me. You are my junior. And I say, come. And I'm your senior. And you are very small. You're not even big. Because some big junior can discipline some big senior. Some small senior. Yes. Especially when they are just alone. But now you are small. Come. What class are you? And I'm looking at him. I'm in SS3. And I ask him, you, what about your class? I'm in GSS3. And then the one in GSS said, kneel down there. And he's not carrying any gun. No, nothing. And he's small. If I say, if I come near you, if I slap you, you will die. You will die. But he didn't train you at home. I will train you today. But it's below you. So copper, mercury, silver, and gold are not displace hydrogen. Surprisingly, we have mercury in the option. Abi can never be the answer. We also have copper. So those two are disqualified. The one that can displace me, there are two in the option, Abi. What and what? Iron and lead. Of the two of them, iron and lead, which one is more reactive? So that's the answer. You pick iron. You pick iron because it's more reactive. So, but you have been told that iron does not react with steam and it is zinc that does not react with water. It does not even react with steam, except if that zinc is what? Very hot. Very hot. But iron can still react with hot water and steam. So the answer is iron. Iron. So the higher you are on the periodic table, the more reactive you become. That it says, coal fire should not be used in poor ventilated room because of the accumulation of CO, which causes deep sleep. Deep sleep. Deep sleep. That's sleep of death. So A is wrong. It is usually too hot. CO hot. That's why CRB. It's vocation. Because it's your CO will combine with the hemoglobin, forming carboxy hemoglobin. The function of the hemoglobin is to take oxygen to every part of the body. When you breathe in, hemoglobin will pick the oxygen and take it to every part of the body, including the brain. But if the hemoglobin is now engaged by CO, there is nowhere oxygen will now get to your brain. What will now be getting there is carboxy hemoglobin will now go there. So CO will be going to your brain and all part of the body where oxygen are needed, then you are in trouble. You suffocate. 37. The major component of the slag. Have you been taught iron? Thank God. So I don't need to explain this one. The major component of slag is calcium what? 4. That's a D. 38. Sodium hydroxide should be stored in properly closed container because now there are some substances that are hygroscopic. Have you been taught that one? Thank God. Hygroscopic, deliquescent, and what? Fluorescent. 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 Hygroscopic, it will absorb moisture and become sticky. It didn't turn to solution and become sticky. It was in liquid form before, absorb moisture and become diluted. It didn't turn to solution. That's hygroscopic. The liquid will absorb moisture and then dissolve in it, and become a solution. A fluorescent can give out water of crystallization. Is Father Christmas. Take water, take water, take water like that. That's it. So sodium hydroxide is highly what? Highly deliquescent. Not hygroscopic now, highly deliquescent. So if you expose it, it will absorb moisture and then turn to solution. So you have to keep it in a very airtight environment that will be free from all forms of moisture. Because the guy is thirsty for water. So by the time you open it to water, it will absorb the moisture and turn to solution. So A, readily absorb water vapor from the air. That's correct. So that it's easily oxidized by atmospheric oxygen, turns gold, yellow, no? So answer is A or B, because it is highly deliquescent. Highly what class? That's it. 39. To make color glasses, small quantity of oxides of metal, which form color silicate, are often added to the reaction mixture consisting of these. Now, transition elements are colored elements. Have you been taught transition elements? Okay, they also teach you. 1, they have variable what? Oxidation states. That's one of their characteristics. Variable oxidation states. Number 2, they are colored in nature. Colored in nature. Number 3, they are catalytic in nature. Can use them as catalyst. You want to mention nickel now, mention iron. catalyst or catalytic in nature. So consider these are the major one variable oxidation states. They are colored catalytic or catalytic in nature. And one of the I've said it that one many times. See, Mr. Copper has so many forms of color. Copper alone like this, now brown. I've said it before. Copper 2 oxide, now black. Copper sulfate without water, now white. Copper sulfate with water, now blue. Blue. Copper carbonates, now green. Copper sulfide, now black. So Mr. Copper has varying color. So we are thinking about, I have just formed my glass and I wanted to add something. Then of course add copper. So the answer is copper. But copper has a lot of varieties of color. So why is that possible? Because Mr. Copper is what? A transition element. So why is zinc not a transition element? Zinc is a fake transition element. Because all its d orbitals are filled, all its s orbitals are also filled. So it's like a very strange one. It's the last member of the first transition series. So everyone know the judge, they look at my face. No problem. Number 40. The following compound gives a yellow residue when heated, and also react with aqueous sodium hydroxide to give a white gelatinous precipitate soluble in excess sodium hydroxide solution. There's one major compound in this world that has another transition color. When it is hot, it has a different color. When it is cold, it has a different color. And his name is zinc oxide. This guy is yellow when hot and white when cold. Yellow when hot. And what class? White when cold. I beg in the name of God, don't be tired. The people I'm beating now are those in the ground floor that I'm not seeing face to face. Will I be sleeping? Put your head on somebody's shoulder. I'm not coming down to check what is going on in the ground floor. Never. Will I play? Will I carry phone? Who call me? Yellow when hot, white when cold. Zinc oxide. White precipitates with what? White precipitates to give a white gelatinous precipitate. White precipitates with sodium hydroxide soluble in excess. Now, there are three substances in the world. Some of you have done chemistry practical before. There are three cations in the world that will give us white precipitate soluble in excess what? Sodium hydroxide. And all those cations are the what? Are the cations of amphoteric elements. Cations of what? So give it to me. What are they now? Zinc ion. What again? Lead ion. And what? Aluminum ion. Those three. Those three will give us white precipitate soluble in excess sodium hydroxide solution. No wonder they gave you aluminum sulfate. They also gave you lead carbonate. They generally gave you all of them. They gave you zinc carbonate, aluminum sulfate, option B, and lead carbonate. They gave you the three. They gave you the three. And from there, you can see that the answer will still be what class? I can't hear you. Why is it B? Because yellow residue. Yellow residues. That's the reason why. That's it. So the answer is zinc. Where is Princess in top floor? Where is Miss on my... Chitashuku, your class normally is where? So why are you here now? because I said you should be here. Because it's seriousness to be face to face with a lecturer. Some of you are just naturally stubborn. So that's a question. Let's go now to number 11 to 20. The last part. We have 5 minutes so that we can 11 to 20. Eleven to 20. We don't have time. Quickly. Try. Don't be looking. Don't just sit down. Try. Can I get one? Can I get two? What is the difference between liquefaction and condensation? Liquefaction is done under high pressure. Liquefaction is just a natural process. Why condensation is natural process. Since HNO3 is a mixed anhydride, who taught you that one? It is NO2 that is a mixed anhydride. NO2, not HNO3. So everyone not solving any question. They're just roaming, just going up and down. Someone sitting down waiting for correction. We try them. Now number 18. That 1.9 is 0.19 gram. Number 18. That 1.9 gram is 0.19 gram. 0.19 gram. Number 11. X gas give us S minus. Now, for you to become S minus, that means you have gained electron. Electron gain will lead to negativity, while electron loss will lead to positivity. And because you have gained electron, the amount of energy required, the equation should have been written this way, plus electron. This should have been the ideal equation. You have gained electron. So the amount of energy involved when you gain 1 mole of electron is called electron affinity. That's the answer. Electron affinity. Electron affinity. So the answer is D. Now, if you're like this, S gas, you now lose 1 electron. now become this. You know, we lose electron like this. That's called ionization energy. So that means you are losing electron. This one you are gaining. That's electron affinity. So this is electron affinity gaining. And this ionization energy. Mr. Adams, what then is electronegativity? Two of us want to do business. So yeah, let's start business. Yeah. Me, I don't have experience, but I have money. I have experience. I have PhD in marketing, and I also did my MBA in California. Very good. Me, I have 27 billion, but I no go school. I got it through inheritance. So what do we do? Yeah, let's start business. Oh, yeah. This one now brought billions. This one brought experience. And the one that brought experience that has no money, what did he do? He now went to create a trap for the other one. Because that one no get, no book. So it's a trap. He wrote a lot of contract statement and everything with a lot of strange things inside the contract, and the guy cannot read. He said, okay, waiting be all this, now contract something. What I go do? Just put your thumbprint. You know if he sign. Just put thumbprint. And the man did not read. Asked nobody to help. Boom. And that's how he thumbprinted his death warrants. And then this one now begin to pull all the resources to himself. This is the one that has no money. Begin to draw to himself. Begin to draw. And then this now is not even going to become a fully ionized, become delta minus. And this one now will become delta plus. That process whereby one element attracted the bonding electron that was shared previously to itself is called electronegativity. I brought one electron, she brought one electron, we'll now share it. Then, after some time, no more relationship, that become a cold relationship, and I begin to drag the two electrons to myself because I have power. So that process is called electronegativity. And then the one that can draw the electron towards itself more is called a more electronegative element. So the drawing of bonding electron towards oneself is electronegativity. Energy involving the addition of one electron to me is called electron affinity. Energy involving me losing one electron is called ionization energy. So the answer is D. So we move to number 12. Chlorine consisting of two isotopes of mass number 35 and 37 has an atomic number of 35.5. Rating abundance of the isotope of mass number 37. Now we don't work this one in the exam. We don't waste time. It's a constant value. Chlorine 35 and chlorine 37. This one has 75% abundance, so don't need to work. We don't work it. It's at 25. It can be worked, but don't need. So it's constant. So the abundance of this guy is 75. This one is 25. But can we work it? Why not? You want to waste time. 35 Cl, this Cl, sorry. Let it be X. Then 37 Cl. Let it be 100 minus X. So how do you get that 100? Total percentage is 100 in mass. So that one will now be S all over 100 times 35 plus, this guy is 100 minus X. 100 minus X over 100 times 37. What's our value? 35.5. That's it. So now this one will now be 35x over 100. We're calculating. Plus 3700 minus what? 37x all over 100 is 35.5. Now find the LCM. 100. So now I have 35x plus, this one cancels this. You have 3700 minus 37x equals 35.5. Okay? Then we're going to have 3700. 35x minus 37x minus 2x equals 100 times 35.5. 3700 minus what? 2x is 3550. Then 3700 minus 3550 equals what? 2x. So I already get 150 equals 2x. So S is 75%. Now, the reason why I show you the working is because it will not be chlorine tomorrow. It will be another element. So you calculate it like that. But if it is chlorine, it's constant. But it's not chlorine. I'll show you the method though of solving it. X all over 100 times the atomic mass of chlorine plus 100 minus X over 100 times 37 is this. So people are not writing this one because they're tired. I beg. I can't keep myself. Let's go. What's the next question? Number 13. 13. 10 dmk of air containing iodine sulfide as an impurity was passed through a solution of lead nitrate until all the iodine sulfide had reacted. The precipitate of lead sulfide was found to weigh. You have not been taught stoichiometry, but if you are following what I'm teaching now, you can get all these things once. Look at this. PBS. What are we to find? Passing by a volume of hydrogen sulfide in the air. Hydrogen sulfide. They mentioned what? What was found? The president of Venezuela was found to weigh. So we are interested in this guy and this one. So how do you know that what we are interested in is there? They said, find a passing by a volume of hydrogen sulfide. And they mentioned the mass of lead sulfide. Very simple. You don't need to know stoichiometry before you know it. Luckily for you, they have given an equation. What will I do? Hydrogen sulfide, is it a gas or liquid? Gas. So I'll just use the gram molar volume for it. What is it? 22.4 dm cube. I don't need to go and start finding molar mass because they're looking for volume. Let's do for lead. Now, what is lead? What's the value for lead? What's the mass for lead? Check in the question. Is that the atomic mass of lead? 207. What of sulfur? Add the two of them. 239 gram. 239 gram. I'll now say V unknown. What's the mass they now give you in the question? 5.02 gram. So now I have 22.4. 239 V. 22.4 and 5.02. Our V will now be what? 22.4 times what? 5.02 over what class? 239. Calculator, what do you get? 0.47 dm kibabi. Want to find percentage of what? Hydrogen sulfide. Oh yeah, how much hydrogen sulfide is now there? 0. What? Total volume of everything before. Check the beginning. 10 times what now? 100. See that? This is the volume of hydrogen sulfide. Total volume of everybody was 10. It's 10. So the answer is 4.7. It's 4.7 there. That's it. They're not difficult. Don't say I hate calculation in chemistry. Don't hate it. Don't hate it. Learn. With some of these examples, if you go to a park and start solving calculation on chemistry, you start getting them. Don't wait for teachers. Now 14. Now, I just answered this number 14 for you recently now. A blue solid, which way? Look at that word, solid. which weigh 5 grams, was placed on the table. After 8 hours, the resulting pink solid is still solid though. Solid. After absorbing moisture, it now remains solid again. Look at that word, solid to solid. It can be in further substance. T is what class? Hygroscopic. Because it does not turn towards solution. The answer is B. The effluent of an industrial plant used in electrolysis of concerning brine. Class, electrolysis of brine. What is the major product obtained from electrolysis of brine? I can't hear you. Chlorine gas. You've been taught chlorine. Chlorine is the major gas. So chlorine will be emitted. Look at what they said though. The effluent of an industrial plant using electrolysis of concentrated. The effluent of an industrial plant used the electrolysis of concentrated brine with a flowing mercury cathode may contain impurity. Now, there's a flowing mercury cathode, and then the major element emitted is what class? Chlorine. When you have electrolysis of brine, you have chlorine. There's a mercury cathode as well. Mercury is a very dangerous pollutant. A little trace of mercury in the river, just see the fish, early in the morning they are dead. Just see them floating, that's the word. Small trace of mercury poison. They are dead. So chlorine is obtained during electrolysis of brine. Mercury now is now flowing there as well. So when mercury combined with chlorine, what are you going to have? That's the answer. Mercury to chloride. The answer is C. So why not oxygen? Class, is oxygen poisonous? Oxygen is not impurity. Hydrogen chloride is not impurity. Hydrogen also is not impurity. Mercury chloride, a little amount of that can destroy, aquatic organisms. Oh yeah, let's go to 16. Solubility in moles per dm cube. That's simple. Let's find the molar mass of copper sulfate. Are we given? We'll find it. Copper is 3.5. Sulfur go. Oxygen go. Add all of them, what do you get? 1.5. Solubility. The formula for solubility is what? 1000 m over mv. Can use this formula. Direct. So you have 1000. What mass are you given? Check. How many grams or something? 20 grams. What's the molar mass? 159.5. What's the volume or mass of water? 100 grams. So about it is gram. Why is it volume? Yes. 100 grams of water is the same as 100 cm3 of water. Why? Density is mass over, and mass of water is, density of water is 1 gram per cm3. Mass 100, volume we don't know. So now the same thing. 100 cm3. Calculator, what's your final answer? I can't tell you. 1.25 moles per dm3. If you had not put answers in all these questions, mark it. If you have not marked it rather, then another time, maybe in the evening today, maybe tomorrow, maybe another day, and then you stay in one corner, maybe in your hostel there, and then you time yourself 1 hour and see how many you can get now. You'll be shocked if you are serious and you listen in class, you can get 40. Even without knowing many chemistry questions before. For some of us, I'm sorry to say, this question that I'm solving now, stressing now for about 4 hours now, give me analysis and everything. Let them give you the same question, this same one, next week, Friday. Some of you will not get 10. Why? Because you are not serious with what you're doing. So people see my being in class today like punishment. It's stressing us too much. Why are we this weekend? I'm not stressing you. I'm not looking at 41 days to the exam. So I can go to school. Let me ask you a question. Which place do you think is more interesting or more relaxing for me to be? Teaching or being in a wedding? Wedding. I'll be hearing good music. People will be hailing me, that's Mr. Adams. I also see by many occasions, that's Mr. Adams. It is only in Adams College that you people don't recognize me. Yes, or appreciate me or honor me, but everywhere, that's Mr. Adams. Mr. Adams. ambitious. Someone will come to me. Honestly, I'm not bragging. So can I have selfie with you, sir? But me sweating here now. Do you think I'm enjoying it? No. Number 15. Number 17. Have you done colloids? Thank God. Smoke consists of what? Solid dispersing gas. That's B. Your perfume consists of what? Liquid dispersing. What type of colloidal solution is that? Aerosol. Aerosol. What type of colloidal solution is liquid dispersing liquid? Emulsion. Emulsion. Good. That's good. 18. Sodium oxalato. Now, no oxalate. Oxalato. That's TO. Given a solution of 0.19 gram of sodium oxalato in 50 grams of water, our true temperature, calculate the minimum volume of 0.1 molar calcium what? Chloride required to produce maximum calcium oxalato using the above equation. Oxalato. Oh yeah, that's true. Let's go through this pain. After today now, we have 5 more Saturdays, so a jam has come. Last year, Easter break, I taught them on Easter Saturday and Easter Monday. I came to Adams. I don't give a damn. People that will cry. That day I left Adams College Easter Monday around 10 p.m. teaching. Yes. I was there till night teaching. So everybody know Adams is doing his best. So nobody can stay here. The man is not helping us. Look at this calcium chloride. Sodium chloride. Given a solution of 1.9 gram of 0.19 gram of sodium oxalato in 50 grams of water at room temperature, calculate the minimum volume of what? 0.1 molar. Oh yeah, but it's simple question. Simple. Just go and find molar mass of this guy. Sodium is 23 Ab times 2. What of carbon? 12 times 2. What of oxygen? 3 times 4. Oh yeah, this is 46. Plus what? Plus what? Get the value. 134. Let's find his number of moles. Number of moles is mass over molar mass. And what's mass? I can't tell you. 0.119. What's molar mass? 134. Divide, what do you get? 0.00147 moles. 1417 moles. That's for this guy. They now said, calculate the minimum volume of calcium chloride. Oh yeah, this one now. Now look up. They're asking for volume. So I won't use mass over molar mass again. Class, the number of mole here, the number of mole here, are they the same thing? They are the same. So number of mole I got here, I will use it for this guy. So I was the number of moles of calcium chloride. But if there is 2 here, then I will multiply this number of moles by 2. But it's 1. Number of moles of calcium chloride equals number of moles of what? Of the first guy, Na2, C2O4. Now, because they're asking for volume and they gave us concentration. See formula for number of moles. CV over what? 1000. It is something in DM keep. It's in DM keep. So there is no need for 1000 again. CV. Number of moles is CV. And what number of moles of the sodium oxalato that we got? 0.001417. I'm looking for what is this? Concentration they gave us 0.1 and volume was 0.00417. 1417. So our V will now be 0.001417. All over what? Calculator, what do you get? 0.01417. DMQ, Abi. Let's convert it to standard form. What will it be? 1, 2. What's that? 1.417 times what? Is it there? That's it. 1.4. Corrected it to 2 decimal places or 2 single figure. So for the 50 column we did, I don't even know many of them. That's why we are doing revision. So because we're going to do many before your exam. Many. Up to the very soon, you'll be leaving lesson late. So my pain is just my hostel student here because you have to sacrifice some sleeping time. So we adjust your prep time. So I can still rest. Okay, so let's go to. They may not all be clear also. Still meet people. Meet people. One family, one love. Meet people. Number what now? 19. 2 grams of a monobasic acid was made up to 250 cm cube distilled water. Look at when you have monobasic acid, that means it has what? One replaceable what? You can just write HS. That's it, monobasic. So what if we have dibasic? You have H2X. Tribasic, H3X. But it's monobasic, HS. Sodium hydroxide, aqueous. So I'll give us sodium X plus water. Oh yeah, look at that. What are we looking for? The molar mass of the acid. 2 grams of a monobasic acid was made up to 250 cm distilled water. 25 cm of this solution require 20 of these for neutralization. What is the molar mass of the acid? Very simple. Class, many of you have done Waec before, and those are planning to do Waec. CAVA, are we? Over CBVB, number of mole of acid. Oh yeah, now, considering of the acid, we don't know, CA. How much volume of the acid was used for transpiration? 25, Abi 20. 25. Abi? Read it very well, you see there, 25 cm cube. What is consumption of the base? 0.1. What volume of the base was used? 20. What's the number of mole of the acid? 1. Number of mole of the base? 1:1. Chichim. You have CA times 25. 0.1 times 20. CA, what will it be? 0.1 times 20 over what? 25. What's the value? 0.0 mole per. But what do you say we should find in the question? Check. Molar mass. Molar mass. Oh yeah, look at this formula. Number of moles. Number of moles is what? Or I give you one formula for solubility. I can also use it for concentration. Concentration is same than solubility. Concentration is 1,000 small m, Abi, over what? MV. I gave you 1,000 small m over MV. Oh yeah, now concentration, how much are we given for the acid? 0.08. Check. How much mass of the acid was dissolved in water? 2 grams. We're looking for the molar mass, Abi. Unknown. What volume of water was used? 250. 0.08 times M times 250 will now be 2,000. Our M will now be what? 2,000 all over 0.08 times 250. What is 0.08 times 250? 20. So what's your M going to be? 100. Is 100 in the option? Look at chemistry. Very interesting. So I want to beg you to start developing interest in it. And even though we don't like it, develop interest. Okay, number 20. The concentration of hydrogen ion, a mole per dm cube of a solution of pH. Pino has taught you that very well. pH is minus logarithm of hydrogen ion. How much pH do we have? 4.398. So minus log. What's the hydrogen ion? Unknown. Now, there's a 10 here, don't forget. So I'll transfer this minus. You have minus 4.398. It was log base 10. For your main exam, they won't give you this type of question that has decimal. But that will be difficult for you to get the value using scientific calculator. So you have this hydrogen ion concentration. Oh yeah, what do you get? 4 times minus 5. So we are through with the chemistry. I want to run through what we have done so far in our 3 minutes. So don't look at your notes. I can ask you. Who can tell me the name of the catalyst used when you are converting ethane to benzene? Yes. Thank you, my baby girl. Organonickel catalyst is in your note too. How many types of alkane do we have? Raise your hand. I don't want chorus answer. Yes. 2. What are they? Terminal alkyne. Don't waste much time. Yes, I'm just checking. Yeah, it's one of the things we have done. The reaction between ethanol to ethene involved the use of conc H2SO4. What is the function of the conc H2SO4? Raise your hand. Yes. Dehydrating agent. Dehydrating agent. Then your notes. Which of the petrol fraction is a very good fraction? Raise your hand. Yes. The branch chain petrol. The branch chain. That's 2,2,4 trimethyl pentane is in your notes. Members of different homologous series that are isomers are called functional group isomers. They're in your note. We've been done all this in just now. Functional group isomers. Okay, let me look at another one. I will need to know. Yes. What is the color of copper 2 oxide? Yes. Black color. Very good. Black. Which compound is yellow when hot and white when cold? Zinc oxide. Very good. Very good. Very good. So this is 12:11. I don't need a break. I've taught from 8 o'clock by God's way till 7 before. So it's not that maybe I need break. I know some of you, your sitting posture is strange. Yes, and it's because we are lazy. But I won't complain. So I'm going to give you 10 minutes break. So by 12:21, we're having physics. The break start now. The break time start now. The female students who are not hostel students cannot go to that top floor, you know, to disturb the hostel, except those who are Jubilee students who are here. Jubilee students here can, and then no boys is expected to go to the top floor for any reason. Physics won't take time because we have done virtually everything in the syllabus except 2 topics, so it's easier. Amount over volume. Yeah, but I don't like that formula. Somebody said we have to look for relative abundance of 37 cl. That means it will be 25%. The one for 35 is 75. So that means 100 minus x. Michael, let me have my question for physics. Michael, where's Michael? Please, the governors in the classes should come and collect question. If you are HOH from your floor, come and collect question. They spread yourself and give them row to row. Give Ugoji to share some. Give some to her. I want to assume you all have questions in all the floors. Let me have the remaining question. If you don't have question, please come for question. The governors and those HOH in the ground floor should come for question if there's no question there. I'm sure in this floor we have enough in this floor. We don't have question on the ground floor. Governors, come and collect question. Or HOH in the floors. We don't have question. In the ground floor, please collect one. Let me have the extra question for this floor. We're waiting for ground floor. If we don't have question, governors come and collect or HOH of any floor. Let's go now. Question 11 to 20. You have 5 minutes. Ground floor, if you don't have questions, we have so many questions here. Come and pick them up. Governors or HOH who are there. 11 to 20, 5 minutes. Your time has started. You don't have questions. We still have many questions at this floor. Maybe you come for it yourself. Or the governors. Or if I HOH of any of the floor, you can come for question for them. We are solving question number 11 to 20. You don't have question, come and pick question here. You don't need to share questions. We have many questions left. We have 55 seconds more. We are doing 11 to 20. Eleven. In a gas experiment, the volume of the gas is plotted against the reciprocal of the pressure. Volume. Reciprocal of the pressure. We're going to have this. Want to find the unit of the slope of the resulting curve. This slope. Our slope is always changing vertical, or changing horizontal. You know, that's it. Volume. In physics, volume is, you want to use dimension, there's no problem. You know, because here now we're having, can use dimension. Volume is meter cube. Want to use length and breadth and height. You can say meter cube. Volume is, the unit of volume is meter cube. Meter cube. Then pressure naturally is Newton per meter squared. That's force over area. So we now have 1 all over this pressure, Newton per meter squared. So what are you doing? Volume is meter cube. Pressure, this is unit of pressure. So now I have meter cube divided by 1 over Newton per meter squared. So that will now be meter cube divided by 1 over, got the minus 1 will go up. To go up, that will be meter squared, then Newton. When you are dividing, what do we do? Turn it upside down. So we're going to have Newton on top, meter square below. Meter square cancel, we have meter. So the unit will now be Newton meter. And Newton is the unit of what? Force. Meter is the unit of distance. First and distance is what? Walk. That's the answer. Some people know it is walk, but I don't know the reason why. I've done it before, now walk. So you have to know. So I use the unit to get that. Volume is meter cube. Meter cube. That's volume. Length times breadth times height. Meter times meter times meter. Pressure is Newton per meter squared. Because it is 1 all over. To be 1 over Newton per meter squared. Okay? And because of the minus, it will go up. Division means you turn it upside down. 12. A cell of internal resistance, small r, is connected to an external resistance, resistor R. We have done this one before. For you to have a very efficient cell, number 1, the internal resistance must either be negligible or the resistance is much greater than the small. That's a D. Is in your note. We have answered it. That in which of the following diagram represent the magnetic field of two isolated unlike poles. Two isolated unlike. Now, unlike charges with what? They use the word unlike, and they are drawing north and north, north and south, south and north. They didn't draw a diagram very well. So option A is north, and because all the arrows are going up. They are going out, so they made a mistake. It should have been north and north. So the answer is A. Change that S to N. North and north. So why is C not correct? Because one arrow they enter, another one they come out. For the same pole of S, if you look at that option C, that is the arrow was going out, another arrow was coming. That doesn't make sense. So it is north and north. They didn't draw it well. So the answer is A. They mention unlike pole. Okay, so for unlike pole, that means north and south. So the answer will now be D. D. Unlike pole, D. D. So leave that one the way it was. I didn't see unlike pole. I thought it was like pole. D. Number 14. The production and type of charge of a body can only be accounted for. Look at that one. We have done that also in class. What makes you negatively charged or positively charged is whether you have excess electron or deficient electron. The answer is A. Deficiency or surplus of electron. If you have more electron, then you are negatively charged. If you have deficient electron, you are positively charged. 15. The main purpose of the transformer than AC. Transformer can be used to step up or. Now, you are now in an AC radio set. AC always take higher currents. So when you have main purpose of the transformer in an AC radio set is to A, increase the power to the radio. There's nothing that has to do with power. Convert energy from AC to DC. That's not true. Step up the voltage, step down the voltage. What's the answer? I can't hear you. Step down, because the voltage may be too high coming from NEPA. So you need that thing to bring it down to 220 volts. So the NEPA make mistake, they bring unnecessarily high voltage. And then you see some of those things exploding. So step down the voltage. 16. An electric heater with a PD of 240 volts connected across its terminals has a storage resistance of 960 ohms. Power. Power rating. Power is V squared over, that's power. So our V now is 240. So I have 240 times 240. What's resistance? 960. 240 here 1, here 4. So what's the answer now? 60 watts. 60 watts. Number 17. If the capacitance of a capacitor C is C, the following parameter is varied when a variable capacitor is used for tuning radio sets. It's varied. I've told you before that capacitance for vacuum, capacitance is what? E not A over D. This one is a constant. This is constant. That means you can say C depends on area and C depends on what? Distance. So the answer is area and the answer is B. Number 18. When an AC voltage is applied to a capacitor, no power is consumed. Now for AC, for capacitor, the voltage lag behind the current, whereas current is what? Leading the voltage. So what's the answer? That thing is in your note, but you'll be sure that some people still miss it. They miss it now. And we did it not last year, we did it this week that is just going. Some people still miss it. Why? They don't read. And it's in your notes. 19. The capacitance of a parallel plate capacitor when in air is 3 microfarad, and in the presence of dielectric material is 6. So all this, I can say, phase is much easier because we've done most of these things. So that electric constant is capacitance for material Capacitance for what? Vacuum or air. For material, how much is the value? 6 microfarad. What are for air? 3 microfarad. So what's the answer? 2. 2. Then the electrolyte in nickel ion accumulator is also in your notes. That's 9 feet. Cloud, what's another word for nickel ion accumulator? Alkaline accumulator. So the answer is potassium. That's it. Let's go now. 21 to 30. 5 minutes. Don't waste time on a question. But this are true. Let's switch off that thing. 21. Nobody should miss 21. That was our last topic. Abby? Doing electrolysis, 20 grams of a metal. So I have M1 over what? M2 equals what? I1, T1. That's it now. So we forgot formula within 1 day. We did it yesterday. 20 grams. So I have 20 here. M2, unknown. I1, what's I1? 0.5. What's time 1? 3 hours. What's I2? 1.5. What's time 2? So hour we cancel hour. Abby? Luckily for this 1.5, Abby. Over 1.5. So they will cancel. 20 over M2 will be 1. So M2 is 20 grams. Is that the answer? You got that one, raise your hand. Let me see. Very good. You should all get that. Can see if we're doing chemistry, we're sweating. You guys don't know chemistry. Can you see fees now? You are plastic. An ammeter of resistance 5 ohm has a full scale deflection. Want to find the resistance of the shunts, Abby? That's 23. 22. When an AC supply is connected to a lamp, it lights with the same brightness as it does with a 12-volt DC battery. The RMS value of the AC supply is 12, Abby. It's in your notes. Go and read it. Root mean square value is defined as the value of the AC that will produce the same heating or lightning effect as that of, it is called DC what? Equivalent. 13. 23. RS IGRG over what? I minus IG. What's IG? Are we given? Current flow into the carbonimeter is 50 milliampere, not 5. That's 0.05. What's the resistance of the carbonimeter? 5 ohms. How much current do we want to measure now? 5 and 0.05. 0.05 times 5, all about 4.95. Abby? This is almost cancelling this. Answer is 0.05 ohms. Abby? That resistor must be in series or parallel. Parallel. Shunt must be in. Must they have low resistance or high resistance? Low resistance. You can see the value 0.05. 24. The motion of smoke. Smoke is always moving in what? Random. As I say, random motion. Then experiment to determine the terminal velocity. As the pressure increases, what to the viscosity? It what? It increases. C. It's in your notes. You see A? Is A increases? Okay, A. Yeah, you can see that I'm making some small mistake here and there in terms of writing A or C because I'm stressed. Stressed, under pressure, stressed. So we are doing it so I can pass. 26. A shooter wants to fire a bullet. So that his original range is equal to 3 times his maximum height. Look at that. Range. 3 times his maximum height. That's projectile. And we'll soon finish the entire syllabus, so we're going to start afresh, just like with where we're doing for mass. So range is u squared sine 2 theta over g. Maximum height, u squared over 2g. So u squared cancel u squared, g cancel g. So we're going to have 2 sine 2 theta because I'm implying equals 3 sine squared theta. Now, see, this is physics. This is physics. But we don't know math, you can't solve it from that place. And it's physics question. That's why when I see medical students walking out of math class, I just shake my head for them. Then the strangest thing is you now see engineering students walk out of further math class on Friday when K Square is teaching. Because you cannot solve this now. Can't. In math, sine 2 theta is 2 sine theta cos theta. And that's further math. And then they expect that a science student should know it. They expect you. But math class, you can't stay. So we're going to have sine squared theta is sine theta and sine theta. Sine theta cancels sine theta. 2 times 2 is what? So you have 4 cos theta. Will now be what? 3 sine. These are under further maths now. Cos theta go down. Yes, sir. 3 come here. Yes, sir. Will now have 4 over 3. Will now be sine theta over what? See further maths. What is sine over cos? Can you see? Tan 1.33333333. That will now be octane. I look like 53 degree. 53 there. That's it. That's physics, your voice. Further mass and mass. You go to some past question now, and they will say that question now, no answer. Because they cannot solve it. So we move to number 27. So that one is not clear. That's why you have friends. And if none of your friends can help you to go through, then you don't have friends. So choose wisely. 41 days to the exam. Your friends should be those who can help you to pass. Not gisting partner. 27. If the area of the earth is 6.4, that's R. That's reference per 6 meters. The escape velocity of the earth, then G is 10. For the new students, escape velocity for the earth, you don't have to work it. For those who are new, the value is constant, 1.13. That's reference per 4. So it's a constant value, so don't work it. The answer should have just been A. If I want to work it, can show working. Escape velocity square root of 2gr. That will be 2 times 10 times 6.4 times power 6. That will give us 128 times power 6. That will be 11.3 times 10 power 3. 1.13 times 10 power 4 meter per second. Where's Serena Adeoye? She has gone home. $28. The component of vector x along the direction of vector y is 0. Look at that. Many of you will miss it. Because you're going to go and pick their parallel. Although, if you pick D, you are wrong. Component of vector x along the direction of vector y is 0 when they are perpendicular. So the answer is C. They didn't say, if they said, what is the angle between two parallel lines? 0. What is the angle between two perpendicular lines? 90. But they're not asking for that. They said, if you have a vector like this now, it is 5 Newton. And this is angle 90. This vector, the component of this vector along the horizontal here will be 0. Why? It will be 5 cos 90. And the mass, cos 90 is 0, so that will be 0. So the component of this one along the horizontal will be 0 if the angle is 90. But if they are on this, but if you have this now, 5 Newton, the component of this one along this direction will be 5. 5 cos 0. But look at what they're asking for. They said the component of vector x along direction of vector y is 0 when the angle is 90 between the two of them. Component of this one along this place is 0. So the answer is C. Abi? 29. An engine of a car of power this. They give us power. Look at this. Power is work done over time. Work done over time. Power force times distance over time. Look at this. You can also say force. Now you can see that what they give us, what they asked us to find is, you can see, power is work done over time. So distance over time is synonymous to velocity. That means power is FV. Some of you that don't know the formula. So want to find a force. So force now be power over velocity. What power are we given? 80 kilowatt. That's 80,000, Abi. Then the velocity is how much? 32. So what's the answer? 2,500 Newton, Abi. To 5. Number 30. What is the correct unit of energy density? Class, density is what? Very good. Density is mass over volume. So when you hear density, mass over volume. Density is mass over volume. Look up 30. But energy density will now be energy over volume. That's it. Energy over volume. That's energy over volume. Normal density is mass over volume, but energy density is energy over volume. Now, energy, look up. They're asking for units. You can use dimension to do it. You can say, I remember. Energy is same thing as work. Energy is ability to do work. You can't do work if you don't have energy. So energy is force times distance. Then I can put volume. Let's use dimension. And if I do want, I can say force is mLT minus 2. That's dimension for force. If we don't know any dimension, know the one for force. mLT minus 2. And then the distance is L. What is volume? Length times breadth times height. Length is L, breadth is L, height is L. L cancel L, L cancel L. When this L go up, what will it become? Minus 1, T minus 2. Class, this M represents mass, Abi. What's the unit of mass? Kilogram. L represents what? Length. What's the unit of length? Okay, now let's go now. Question number 1 to 10. 5 minutes. 1 to 10. The diagram for number 1 would have been like this. That's the diagram for number 1. Stress against strain. Number 1, the diagram is like this. Please, no talking, no talking. Practice it. 1 to 10. That boy, yes. What's the question? I can't hear you. You what? Stand up. You don't have question. We have more than 40 questions there. If you don't have question, come and pick. Guys, We don't have question. Come and pick question. What stop you coming to go question? I didn't ask you to go and pick. Just stand there, remain standing there. That boy standing, come and take question now. Question 1. Diagram below represents stress strain graph for a critical metal rod. What does S represent? The breaking point. The breaking point. The wire will have undergone breaking stress at that time. And then it breaks. Let's pass it to him. And it breaks. 2. A uniform solid keep material, 10 cm on each side. 10 cm on each side of mass 700 grams is submerged in water. So the following best describe the behavior. The question is in your notes. If you go there, you will see it. Dimension solid keep. So volume of keep is L raised per 3. And that'll be 10 raised per 3. That'll be 1,000. Same keep. The density is mass over volume. The mass is 700 grams. And then the 1,000. 0.0000. That'll be 0.7 gram per cm keep. That's density. We all know that density of water is 1. Density of water is 1. So by the time you place something like this on the water, the substance on the water, its density is 0.7. Of course, it's going to float. That's the answer, to float. Why is it floating? Because its density is less than density of the water. It will sink if otherwise. So it will float. So what's the answer? B. Number 3, at low humidity. What is the meaning of low humidity? What's the meaning of low humidity? Raise your hand. Who want to talk? What does it mean? Yes. Why? Yeah, we have less amount of water vapor in the atmosphere. Water no day here. Just scanty water vapor in the atmosphere. At that time, what would then happen? Water would like to go up. Through your skin, water would like to go up. So at that period now, you are going to be sweating, and then the water would like to evaporate to the atmosphere. So what will happen to your skin? Dry, rough. Water is going out. You know, low humidity means there is low amount of water here. High humidity means there is large amount of water. That period there will be no evaporation. But now, water will be evaporated from anywhere, from your ear, from your hand, from your nose. Water go they come out. So the skin is usually damp and rough, no? Dry and rough, because there is low humidity. And that happens also sometimes during the harmattan. During harmattan, you have to cream your body very well. Otherwise, even your lips will become dry. You know, people start using lip gloss and all that during harmattan because we have low humidity. You know, so water will be coming out. Your leg will now look like Aboki's leg. You know, I was at the back of one of Aboki one day. He carried me on a car. I wanted to vomit. Unfortunately, the seat was arranged in such a way that your body will be touching the body of the driver. Yes, you know some seat like that. I don't know why they do it in a bike. It's like this, slanting. Be like they can't hug ourselves. I was just praying for me to get to where I'm going very fast. Because the boy, I don't know whether he has not taken bath for 4 days. Yes. The stench can kill human being. Number 4. If the relative density of gold is 19.2. So everyone is saying, some of you are in class today, you didn't take your bath. Yes. Didn't take your bath. You know yourself. It's cold. It's cold. I just wash my leg and my mouth. You are Abuki Junior. Abuki Junior. They know them say they're going to look around. Relative density of gold, 19.2. The volume of 2.4 kilogram of gold. What if I find volume? Now, look at that. Relative density of gold. Relative density of gold. That will be what? Density of gold over density of water. That's anything water is down. For relative density, water must be down. How much relative density of gold in the question? How much? 19.2. What's the density of gold? Are we given? We're not given. Density of gold. What's the density of water? 1,000. So that means density of gold would now be what? 19.2 times what? 1,000. That's 1,9,200, Abi. Kilogram per meter cube. What are we looking for? Check. What are we looking for? Volume. That's the density of gold. And the mass over volume. You are an hostel student. I'm not asking you to name names now. You are an hostel student. You know some hostel students who are not around now. Raise your hand. Raise your hand. If you want to gain admission, raise your hand. Some hostel students you know they are not around. See hands. Put down your hands. And I'm teaching them 6 hours of class. And I'm not here. Density of gold, 19,200. Those who are talking, we need microphone, let me know. I can give you 0.4 over V. What if I'm volume? Now 200 V, 2.4. Our V will now be 2.4, 9,200. Calculator, what do you get? Minus 4. The thermometric property of a constant volume. When your volume is constant, then your pressure must be what? Changing. As I see, changing pressure. They measure constant volume. Some of you still want to go and be changing volume. Constant volume. That means volume is constant. You still want to go and choose A, because A stands for admission. Eshegon. Changing pressure. C. Number 6. An immersion heater rated 2 ampere. That means the time taken to boil the water. Just to boil. So we have PTRE, MC theta. And then we are given P to be VI. You can just say VIT. Because we're not given power straight, we are given volume, voltage. So we have 240. How much current do we have? How given time? What's mass? 2.5. What's C? 4,200. Theta from what to what? Now 48 are we? So our T now will be 2.5 times 4.2 times 7 power 3 times 48 over 480. Are we now? What's the answer? 1 point per 3. 1.05 seconds. 1.05. Number 7. The thermal flask is designed. The function of thermal flask is to prevent heat loss or prevent heat gain. You know, when you are, it's only that we always put, anyway, now the people do it. We always put hot food inside the thermal flask, hot water. You can also put cold water there. and to remain cold, like ice block. So that means it will not gain heat, it will also not lose it. So it's thermoflap prevent heat loss and also prevent heat gain through conduction, convection, and so the answer is what? A. Prevent heat loss or gain by the three. The savory part of the thermoflap prevent heat loss by what? The savory wall prevent heat loss by what? Radiation. What does the vacuum prevent heat loss against? Conduction and convection. The cork, C-O-R-K, prevent heat loss by what? Evaporation and conduction mainly, and then evaporation. Number 8. What is likely to happen if the glass of a thermometer expand more upon heating than the liquid inside? The glass will break, Abby. Thank you for feeling. Yeah, I know say go break. The glass go break. That's a break. Glass go break. Look up. Now, what we call the concept of capillarity. Concept of what? That's it. If you have this, let's have liquid here now. Liquid. Now, let's say, of course, capillarity rise. The liquid may go to this place. Now, the same glass now, you can't apply it. It's now expanded, the liquid, the glass, expanded more than the liquid. That means it's now going to become bigger. And when it becomes bigger, what will happen? There will be capillary fall. You go down. Because the narrower the tube, the what? The greater the rise and the greater the fall too. So when it becomes big like this, the liquid level that was there before will just drop. So the answer is what? The liquid will go down in the stem. Some of you are missing some questions, just smiling. So confuse. Yes, already you are missing many questions. I'm just smiling. So and you are laughing loud so that we think. Now, atmospheric pressure equals 76 centimeter mercury. Pressure of the gas, we've done that before, have we? Pressure of the gas is A plus what? H. Your notes. All these are in your notes too. And that is how much? 76. H is how much? 10. So what's the answer? That's it. Centimeter mercury. Number 10. A drop of petrol makes a finger colder than a drop of water. When we are in primary school, they want to give us immunization. Then the first thing they will do, they'll first use cotton wool. They'll put methylated spirit in the cotton wool and rub that place. And as they are rubbing, it will be tinkled because it will be colder to touch. And the reason for that is that as they are putting that volatile liquid, the guy is going to evaporate because the volatile liquid, it has a very low vaporization value. By the time they are rubbing, just evaporate. And when it is going, it will not go alone. It will go with some heat from that part of the body. That heat is the one that will even evaporate it. So the answer should be A. Petrol takes its latent heat of burning from the finger. Let's go 41 to 50 now. 5 minutes. 41 to 50. Some people are sleeping. They're tired. And they want to study medicine in Unilag. Yorubas, we like party like mad. Just block road. And I was saying there's no money, no money. We have a new child, we'll block road. Buy bicycle, we'll block road. You know, we just like wasting money. Last week I was coming to Adams College. I think on Sunday, they were doing party somewhere. Do you know what they were doing? I just saw the banner. 20 years in mind. 20 years in mind. Their grandmother died 20 years ago. And they are doing party. Yes. The street after I did the street. 20 years in mind. Ah. So what? 20 years ago? That money can be used to give somebody scholarship. Put Malu down and begin to drink. Come on, waste to go Nigeria go. You myself don't die, don't rot. I've forgotten about them. I hope there won't be any Jubilee student that will go and stay in the banquet today and be looking at those who are dancing. And you two shaking your head. Let them report it to me. You go home and join them. Mr. Adams, does it mean that if someone wants to feel very cool, he should pour meditated spirit over his body? Some have brain but cannot think. I can think but I have no brain. You can go and pour. You want to feel cool now? Pour. Now you shh. You now become cool. Then what happened after? Lodo. $41. There's something that I've not done that I won't teach you. For me, I'm going to teach. So I'm not going to be rushing. 41, I'm skipping that. It's on common emitter and common base. 42, the study manufacturer will use to make an N-type semiconductor. Which material will you use for doping? You must use group 5 because N-type, so that's arsenic and antimony. You guess, you are saying yes, as if you know it. You shall guess. So the answer is D, but we'll do it later. A PN junction diode is used as a rectifier. A diode is a rectifier used for converting AC to DC. AC to DC. So the answer is a rectifier in a DC circuit, an amplifier in a DC circuit, a rectifier in an AC circuit is used as a rectifier in a DC. Okay, is used as A diode is anything that can convert from AC to DC. And that process of converting AC to DC is called rectification. It's called what? You know, that means a diode is a rectifier. Convert AC to DC. So the answer is a rectifier in a DC circuit. So if any AC comes in, you can convert it to what? To DC. So rectifier in a DC circuit. That is A. The one I will teach you. 44. An object is placed 10 cm from a what? Concave mirror. The panel has taught you that one several times. Focal length is 5. Now, if focal length is 5, that means our radius of curvature is 10. That means the guy is placed at the center of. So the answer will also be at the center of curvature. Abi? 6. Same side of object. Real inverted and same side. The answer is A. Can also work it. You still get it. A progressive wave equation is written by y is what? A sine 150 pi t. That's pi t, not ft. Pi t. If the phase difference of a progressive wave is 45, the value of x in the equation is, where is s? Oh yeah. Y is a sine kx minus omega t. That's progressive wave equation. There's a sine. Our k is 2 pi over lambda minus 2 pi ft. These are phase difference. These are phase. So we're going to have 2 pi over lambda x. That's our phase. How many degrees are we given? 45, which is pi over 4. Do not go pi over 4. 180 degree is 1 pi. I'll be now. Then 45 degree will be, can call it y. So 180 y is 45 pi. And then your y will be what? 45 pi over 180. 45 here, 1 here, 4. So our y is pi over 4. So pi cancel pi. So you're going to be having, are we given wavelengths? What is the equation? Y is a sine. This one, that 150 ft is wrong. Who has a rib? Anyway, I will check it. Don't worry, I will check it for you. But something is missing in the question. I'll fix it before you go. Don't worry, I'll get it. 150 ft. I'll check it for you. Because here we're going to have 2x over lambda is what? 1 over 4. Because they imply 8x will not be what? Lambda. So what's your x? Lambda by 8. So I'm sure that maybe we are given wavelengths. I'll find out. I'll check it before we go, before we finish that other one. 46. A submarine observed to rise from where to where? A real depth of 80 meters to change in what? Apparent depth. So what's the answer? A submarine is observed to rise from a real depth of 80 to 60. 46. Refractive index is real depth over what? So we have 4 over 3. What's the first real depth? 80. You go and look for apparent depth. You have 4a. Now 240. Have you now? Apparent depth 1. That will now be 240 over 4. What's the apparent depth 1? 60 centimeter. Or is it meter? 60 meter. Then for the second one, n is real depth over what? The new real depth is now 60. So you have 4 over 3. Real depth now is 60. All over a. Chuchum. 4a. Now 180. Our new apparent depth will now be what? 180 over 4. So what's your new apparent depth? 45 meters. They said we find change. We now subtract. We are looking for change. That'll be 60 minus. So what's the answer? 15 meter. (15 meter). (47). Non-luminous object can be seen because the what? They reflect light. Non-luminous. 48. The frequency of the wave in the diagram above. We're going to give it time. 40. Got the root time here. Look at that time. Frequency is what? Number of cycles over time taken. Look up. Oh. Class, as I'm going like this. Like this. Bam, bam. How many cycles is that? 1 cycle. What's time taken for that cycle? 40. And that's 0. What? 025. That's it. Can use many methods to get the same thing. The answer is not there, Abi. Okay. 0.025. That's the answer. Okay, sorry. That diagram is wrong. It's 4.0. Everything is 0.0. It's 1.0, 2.0, 3.0, and then 4.0. So 1 over 4.0 was that 0.25. Sorry, you made a mistake. (49) And of the first overtone of a note in a closed pipe. Look at that word, closed pipe of length I3. The wavelength. Closed pipe. This is a closed pipe. This is the fundamental stage. Fundamental. And here, this is our length. So here our L is what? Pi over 4. That's node to what class? That's lambda over 4. But they're asking for first what class? Overtone. Now we're going to have a complete cycle inside. Be like this. It's been our first overtone. So when you have first overtone, there'll be 1 cycle. Once you have second overtone, there'll be 2 cycles. Second overtone, we'll draw them like this. First cycle, this overtone. 1, 2. First overtone, 1, only 1. Fundamental, you know, get cycle. You know, so this one, L is 3 lambda over 4. Don't multiply by 3. This one, L is 5 lambda over 4. That's it. So our L is 3 lambda over 4. This is first overtone. First overtone. This is second overtone. The third overtone, instead of having 5, what are you going to have? 7. Second overtone. Yeah, what are we looking for? Is it length or wavelength? Wavelength. Are we given length? What's the length? So after 3, will now be 3 lambda over 4. 3 lambda will now be what? 33 times 4. So lambda, what will it be? 33 times 4 over 3 RV. What's wavelength? 44 cm. Last one for that one. I'll fix that number. I'll fix it for you. A person can focus object when they lie beyond 75. When they lie beyond 75. I mean, the guy, look up. The guy cannot read like this. You can only read when they lie beyond 75. That means you can only read when it's like this. According to James chapter 4, So, if you cannot see something near, what are you suffering from? Eh? Eh? You can't see something far. What are you suffering from? You can't see something near. You can't see both near and far. Blindness. Blindness. Press. Yeah. Inability to focus object at far and near. Blindness call. Oh yeah. A person can focus object when they lie beyond 75. That means this guy's near point is 75 cm. Quality of the lens required to reduce this distance to 25 is so our U now is 75. Our V is minus 25. Look up. Anything least distance of vision, they're always negative. And they are visual. Negative, visual. Don't worry. I know Opana has taught you, but we'll still do revision in that area very well. 1 over U plus 1 over V. 1 over F. What's your U? 75. That's 1 over V. What's that V? 25. What's the SM? 75. 1 minus 3. Minus 2 over 75. 1 over F. F is what? 75 over 2. Is that 7.5? That's 7.5. Now, if you don't put minus sign here, you're going to be wrong. Go. You will be wrong. You go and get 4 over 75. That will be 18.75 or thereabouts. And that will be wrong. But we'll still do revision on those areas very well. But I know your chart just taught you not quite long. Yeah, let's try the remaining 5 minutes before we go. 31 to 40. Try. You have tried, but try more. The next 5 minutes. Yes, I was trying to fix that question on optics. I'll fix it now. But let me quickly run through the remaining one. 31. Remember one, work done by load is always less than work done by effort. All machines are made of levers, pulleys, screw, gears, and wheel. A fishing rod is a machine. Effort is always larger than load. All the statement above about machines are true. The efficiency of machines is always less than 100%. Always less than 100%. So efficiency is always MA over VR. Mr. Adam, what does that mean? That means MA is always less than VR. Upon that again, efficiency is work output over what? Work input. That's what? What does that mean? That means work output is always efficiency. Work done on load over what? Work done by effort. That's what? What does that mean? Work done on load is always what? Let's go back now. Work done by load is always less than work done by effort. That's correct. I see it here. So number one is correct. All machine are made of lever. That word all made that one wrong. All machine. Can't be all machine, but some machines, are lever, pulley, screw. Like now, he didn't mention inclined plane in that place. An inclined plane is a machine. So that all made it wrong. So 2 is out. So we have 1. So C, if you pick C, sorry. If you pick D, sorry. A fishing rod is a machine. That's true. Can carry a big fish using a fishing rod. Using your hand may be dangerous. Only gear. Number 4, effort is always better than load. No. But Mr. Dance, MA is loaded by effort. That's true. But if your effort is higher than load, that means your machine has a what? Mechanical disadvantage. We expect the load to be higher than the effort. So that's wrong. So the answer is 1 and 3 only. A mirror with 75 Newton is hung by a cord from a hook on the wall. This is the wall. There's a mirror hung. Look at that. A mirror with 75 Newton. This is 75 Newton now. 75 Newton is hung by a cord from a hook on the wall. There's a hook here on the wall. If the cord makes an angle of 30 degrees with horizontal, there's 30. With horizontal, this is horizontal. That one is vertical. So it make an angle of 30 with the horizontal. Find the tension in the cord. Tension. This is the weight acting down 75. The cord makes an angle of 30 with the horizontal. So I can extend this one backward. By extending it, it will be like a triangle like this. So this is angle 30 degrees. And this is our T tension. And the 75 will not be here now. This opposite is what? Hypotenuse. That's so sin 30 opposite over hypotenuse. I'm you don't like vector. What you don't like, go and practice it. Sin 30 is half, opposite 75. So T is 150 Newton. Type 3. The energy associated with the emitted photon when a mercury atom changes from one state to another is this. Calculate the frequency of the photon. We've not done it, but I'm going to do it. That's what we are starting by going on Monday. I'm so excited because these are interesting physics. Very easy part. Energy in feet HF. That's the formula. HF. That 3.3 electron volt, that will be 3.3. 1 electron volt, they give you the value. It will be 1.6 minus 19 joules. Should have been joules. H 6.6, minus 34. So F. So energy is HF. Now, so why are you doing this one? I'm converting to joules. That's why I multiply with this one. Who has calculator? What is 3.3 times 1.6? 5.28. Abi? 5.28. 6.6 times minus 34F. Our F now will be what? 5.28 times minus 19. All over 6.6 times what? Minus 34. What is 5.28 by this one? 0 points. That stands for what? 15 Abi. So I'm going up. So F is 8.0 times power 14 hertz. Is it there? 14. 34. The process through which free electrons through which free electrons leave the surface of hot metal is known as thermionic. Call it is hot. Tam, use idea, bring power there. Sure, cause you got that one, Abi. Yes, thermionic. It's hot. Obono. 35. All these are what we are still going to do. You will get them. They are interesting part of physics. The battery connection that permit current to flow. If you allow current to flow, that means you are forward biased. Yes, we've not been taught. Don't worry. Those ones are the. We have 2 more topics left in physics, so those are the ones we are going to. Forward biased. One of the properties of gamma rays is that it is neutral. Alpha na positive. Gamma na neutral. Option what? A, neutral. 38. 37. It is 36. 37 now. I'm not tired as I said I'm going. So people will still come and line up in front of my office now. Yeah. They are not considerate. I want to see you. I know you will not allow me to see you. From 8 o'clock, I'm here. Saturday, I should be resting. I should be at the poolside or go to a spa. Yeah, that's what I'm supposed to do, naturally speaking. But now, you still come and line up. I want to see you. I know you don't want to see me. That's true. You will not kill. Then I say, sir, I know you will not allow me to see you. You're not considerate. That's wickedness too. You should be saying, sir, go and rest. Somebody sent a message to me after the chemistry. And that's how I know that some people are thoughtful. Sir, your voice is down. What happened? Please take some rest. That small message made my day. That's a message. Online student too. So your voice is down. You are stressed. Please. That's it. For some of us, we're not considerate. I know he's not going to see me. I've been trying to see him. I will not allow me to see him. And then they will start calling my name and they'll say, the chairman of today is Mr. Adams. He no come. Be like say no come. Disappointed the bride. 37. Which of the following diagrams represent correctly an MPN? Now, anytime you see MPN, I've not thought I'm going to teach transistor, no problem. You don't have a problem with all this physics. MPN. Every time, current always pass through from positive to what? And so, MPN, there will be emitter, base, collector. All those E, B, and C that you saw, that E means emitter. We are going to do it, so don't bother yourself. Don't write anything. I'm just going to give you the answer. The answer is B. MPN. Shut up. Okay, pick answer. I got it. You don't know it. You say you got it. But they do guesswork. I'm not referring to you. So the answer is B. Well, I'll explain later. Don't worry. Radioactive element has a half-life of 4 days. The first that decayed in 16 days. Answer is A, 15/16. Not 1/16 or 15. We'll discuss it later. The theory of electronic conduction in solid, which I finally explained, property of conductors later and semiconductors, is called string theory. Yeah. Who got his string theory? Raise one very well. Raise it very well. Very good. And that band theory. Yeah, I want to catch them. Those guys. Because series I am for string theory. Band theory. We call it energy band theory. I'll teach you, don't worry. Energy band theory. One also, okay, G string. String theory. String theory. 40. Number 1 is band theory. We discuss it called energy band theory. Number 1, the number of neutrons released exceed the number that cause a fission. What are you talking about? Okay, nuclear fission. Number of neutron released exceed the number that cause a. That's correct. There's loss of mass. That's correct. All nuclear reactions involve loss of mass. Energy is produced. That's correct. Smaller nuclei made to form larger one. No. So the answer is 1 to 1. Please, that number, the one that we said, well, I will get back to it. 45. The question is y equals a sine 150 pi t minus pi s over 4. That's the question. That's the question. So what are we to define? Read the question. They say we define what? Class, we all know that y is what? A sine. You can use that one now because they have pi t first. You can say 2 pi ft. And as well, 2 pi x over lambda. X over lambda. So I can say 2 pi x over what? Lambda equals what? Pi x over 4. As we did before. Pi s can cancel pi s. Lambda will now be how much? 8 cm. But what they want us to find is what? X, Abi. Now, who can define wavelength for me? What's wavelength? Between between. Yes, that's correct. What's another definition of wavelength? Use your common knowledge. Who can talk? Oh, yeah, now. Nobody. Yes, my dear. Which number are we doing, Seth? Number what? Distance of one oscillation. Yeah. See me after the class. 1,000 naira for you. One complete cycle is wavelength. Thank you, my baby girl, Barakat. So this is one wavelength. One complete cycle is called wavelength. Complete cycle is a wavelength. Class, what is the length of the wavelength? I can't hear you. 8. I mean, this is 0. This is how much now? I'm showing you something. No? If from here to here is 8, from here to here, what will it be? 4. From here to here, what will it be? From here to here, what will it be? Oh, yeah, now let's go back to the question. What do you say we should find? Find what? When what? -45°. Look up, class. From here, like the pan to this place. How many degrees is this? 180 call. From here to here, how much? 360 now. I'm giving you, okay, if you don't understand diagram, because 360°, that's like what she said, a complete cycle. 360° is 8 centimeters. How many degrees are you giving now? 45° will now be what? X. Now say 360x will now be what? 45 times. Our S will now be what? 45 times 8 over 360. That's 1, Abi. That's the answer, 1. So can we get the 1 from here? Yes, I'm trying to explain what some of you are saying 180. From here to here is 360. Oh yeah. From here to here is how much? From here to here, how much? 90. 90 is 2 centimeters. Then 45 will now be how much? 1. Have a lovely weekend. Thank you. Please stack your share in the ground floor If you don't stack any share, forget about 300 though. Yes. Stack shares. Stack shares. Please give them the fan. Some people are walking away. They are not stacking share. Okay. F 300. Okay. Oh. Don't let your share touch the fan. Oh. Why is that guy not selling his own? I give him on to 20. You are both 70.
This means of lip. Oh yeah, talk. Please talk.
Sadiq Aisha Temitope, your mom is looking for you downstairs. Okoro Joy, Chinoye, your mom is looking for you downstairs.
Hello.
Hello. Koshomosho Fu, Divine Augustine, your sister is downstairs.